Asteroids. So asteroids is one of the mission areas for the Space Ops Challenge. It's going to be this weekend, April 12th and 13th. And so we wanted to bring together some of the people who are working on, who are challenge owners for some of the different asteroid missions, asteroid challenges we'll be working on. And then also just they in general work with asteroids and doing simulations of them. So we'll go first to Phil Metzger.
Hi, how are you? Good to see you again, everybody. I'm Phil Metzger, and I'm the lead of the Granular Mechanics and Granular Operations Lab here at KSC Swamp Works. And we are a space mining laboratory, so we're developing technologies to utilize the resources in space to help enable NASA's mission to explore places like Mars. And studies have shown if we use resources in space, we can cut the cost of a Mars mission by perhaps a factor of 3, upwards of a factor of 5. One of the resources we can use would be asteroids. A lot of the asteroids have hydrated minerals and maybe 20% water composition. And if we could just get water in space, electrolyze it to produce hydrogen and oxygen, perhaps combine the hydrogen with carbon if it's a carbonaceous asteroid. We can make methane, which is more space storable than hydrogen. Then we don't have to launch all the propellants for the trip to Mars, or the trip back from Mars, or the trip down to the surface of Mars, and back up again.
Increase the audio.
So we're very interested in asteroids.
How do I go into the...
I'll quickly spin around and show you some of the lab. In the back, we have a big bin where there are 2 people working today. Now, at the moment, we're testing a space mining robot doing excavation. And over here, we have a 3D printer for making bricks out of Lego. That's this object right here. And this is not asteroid mining, but this is a copy of the veggie payload, which is going up to the space station on the next SpaceX launch to grow crops in space. So that's a little bit about what we're doing. Okay, Kelly?
Thanks, Phil. Okay, and next we'll go to Jose.
Hi, I'm Jose Luis Galacho. I'm with the Minor Planet Center, Cambridge, Massachusetts. Phil said that they want to go find some asteroids, so in order to do that, you need to know where they are. And the Minor Planet Center is the central repository for all observations ever made of asteroids and comets. And we also provide orbits for these asteroids. So if you want to go to one of them, then you can ask us and we'll tell you where the space it's going to be. And what we receive are the actual observations. You can not receive the images taken of the night sky with those asteroids. And I am the lead on the challenge for the asteroid imagery, and it would be of interest, I think, to a lot of people to have a central repository where we can keep all these images, because the methods that we use now to detect asteroids with these images might improve next year, or even in a few months. And if we can go and review all the old images, we may be able to find new asteroids in them or find better positions than the ones that we're already found.
All right, thanks, Jose. And next we'll go to Alessandra.
Hi, my name's Alessandra Springman. I'm at Arecibo Observatory here in Puerto Rico. It's a pretty gray day, otherwise I would put the webcam out the window and show you the telescope. So we work to find asteroids before they find us. We are funded by NASA. We use radar to detect these asteroids. We send radio signals out of the asteroids, they bounce off, and we collect them. So we do observations of asteroids, but we don't rely on the benevolence of the universe for our photons, unlike most of Jose's observations that come from astronomers using telescopes with reflected sunlight. We have a lot of data, not just of where these asteroids are, how fast they're moving, but we also have a lot of data involved in the shapes and sizes of these asteroids, which can also be used to improve their orbits. The cool thing about radar is one detection with radar means you can refine these orbits of asteroids for not just a year, decades, but centuries or millennia into the future, which is kind of neat. I'm not the lead on any challenge, but I'm looking forward to hearing more about what's going on and answer questions about asteroids.
All right, thank you very much. And on to Daniel.
Hi, I'm Daniel O'Neill. I work at NASA's Marshall Space Flight Center, and I own 3 of the challenges: the asteroid mission simulators challenge, the create your own asteroid mission challenge, and the visualize the asteroid skies challenge. And the hope is that we'll get teams that are going to be developing standardized interfaces to some spaceflight mission simulators to enable distributed simulation of asteroid-related missions. Use some of these free spaceflight simulators to create visualizations of the mission simulations, and then to provide, say, web apps to help people visualize data about asteroids from available asteroid databases.
Great, thanks. So we'll go on to our first question. So this comes from Demunina, and can we capture one asteroid everywhere in space or just belonging to the space belt? And so I think this might be related to a specific challenge about whether there's a focus on just anywhere in space or just ones in the asteroid belt. And this could go to anyone.
There's an idea of this ARM mission, the asteroid redirection mission, or the asteroid redirection and retrieval mission, where a mission goes to an asteroid, puts it in a bag, and brings it back into a distant retrograde lunar orbit. The other option is to pluck a boulder off an asteroid, bring it back into Earth orbit for astronauts to study. So this is what's being worked on. I think there's a lot of opportunities to try to detect potential asteroids for these missions, because if you choose an asteroid and it doesn't work out, you're going to have to select another one. So having multiple potential targets when you launch this mission is going to be the name of the game, unlike most traditional NASA missions where you've selected your target maybe decades in the future, at least years in the future years before launching. Now we're going to have to go with selecting a bunch of potential targets and then maybe selecting one after launch.
So I'd like to add a little bit to that. For the near term, for the ARM or ARRM, we're only looking at a very narrow class of asteroids, ones that we could possibly bring back to that lunar retrograde orbit. The vast majority of asteroids way out there in the main belt would require so much propellant to bring back that it would cost trillions and trillions of dollars just to launch all the propellant. So for the near term, we're only looking at bringing back a relatively small asteroid, or like Alessandra said, a boulder. It would be relatively small in mass, no more than 7 tons, and it would have to be in an orbit that's only a couple hundred meters per second different delta V than the Earth is in its orbit around the Sun, because again, the fuel to bring it back would be prohibitively expensive to launch. We wanted to bring in other asteroids. So in the near term, we're really looking at a narrow, very narrow class of objects that we can bring back. In much further future, once we're using space resources, we don't have to launch all those propellants, then that would open up the opportunity for a lot more.
If the question is within the context of, say, the create your own asteroid mission challenge, then you may want to select a free spaceflight simulator that actually has some sort of asteroid database into it. One that comes to mind is Celestia. It already has a number of asteroids, probably primarily from the asteroid belt area, where they have data on those asteroids, and so you'd be able to create a mission simulation to go after one of those asteroids. If the question is in the context of the asteroid simulators challenge, well, then this would be an opportunity to, say, develop an interface between an asteroid database, like perhaps AstroRank, and then a free spaceflight simulator like maybe NASA's General Mission Analysis tool, or say the Orbiter 2010, and then use that distributed simulation interface to get data from the asteroid database for that mission simulation.
All right, well, thank you guys very much. And just a reminder, let's see, we have around to our viewers, so some of you guys have found we do have a Q&A, question and answer portion of the Google Hangout. And if you guys want to enter questions in there, that'll be a great way for us to be able to see them and pose them to our panel. Okay. And then so our next question is from Gregory. Is there a way to determine if an asteroid contains valuable resources that would be interested in exploiting it without visiting the machine to visit it? So how do we determine if there's interesting resources there without actually being there?
I can take this one if you mind.
Go ahead.
So in this case, unlike before when somebody was saying that they use their own photons, if you want to know what an asteroid is composed of, or at least its surface, then you do want to have photons from the sun bouncing off of it. So you can measure the reflected sunlight, and you take it and you spread it out, and you measure how many photons you get from each wavelength. You can create a spectrum. And each type of asteroid has a characteristic spectrum. For example, carbonaceous asteroids are darker, they have a quite flat spectrum. A steep spectrum. And that tells you what the surface composition is, and in some cases you can expect the interior composition to be similar to the surface as well. So in fact, you don't need to visit an asteroid, but it would be of interest to visit an asteroid, because then we can find out if in fact the surface composition is similar to the composition even a few centimeters to the asteroid.
Thanks. Does anyone have anything they'd like to add on to that? Okay, I'll go to the next question then. Thanks, Jose. Let's see. Would we expect to find, this one comes from Daniel, big impact craters in an asteroid? So are there going to be craters?
This one.
Okay.
It actually depends on the asteroid. So if the asteroid's a solid lump and something hits it, you might see big craters on it. But if the asteroid has already been broken apart and is just sort of a pile of rubble, you might not see big impact craters. And a lot of asteroids, actually, every time they get hit, the whole asteroid shakes. It's a seismic shaking. It's like an earthquake, but it's an asteroid event. An asteroid shake. And the asteroid quake can actually shake out the surface so that you don't see evidence of big impact craters. And this can take place over hundreds of thousands of years, millions of years. So some asteroids really you won't see any evidence of big craters on them just because they've all been shaken out. And if it's an asteroid that's just made entirely of gravel, that's barely stuck together, it might just absorb all the energy of the impact. We might not see much of a destructive crater. So it depends on what the asteroid's made of if you're going to see catastrophic craters on them.
All right, thanks, Sandy. All right, and our next question is, and this is about the asteroid prospector, and I'm not sure, they're going to be, and it's in capital letters, REST, so REST an API for the asteroid prospector, or are we going to have to go download a chunk of data and use that locally? So, not sure if this is something that any of you guys are familiar with the REST API.
I'm sorry, can you explain that again, Kelly?
Can you, Phil, do you see the question and answer box? You could go read it yourself. It's our first question.
Okay.
Or it's,
yeah, I don't know about the REST API. I don't have the information.
okay. All right.
I could probably say a couple of things about it. REST is the representational state transfer protocol, and it's a nice compact way of getting data from websites. I mean, it's like putting the query right into the URL, and then of course the website that has the data comes back with the response. And I know on the Visualize the Asteroid Skies challenge, where we're looking for visualization of asteroid data to help people understand how asteroids can affect their lives. The REST API would probably be a good way to go. I do know that the AstroRank database team has a Ruby application programming interface, and they've posted a link in the hack pad for that challenge. But there could be other data sources that have a REST API, and that would certainly go well for developing the data visualization web apps.
Great. Thanks, Daniel. And this is why we have multiple experts together. Let's see. And then we have a question for the Asteroid Watch Challenge. And it asks, is there a minimum size of telescope that is needed to be useful? And the asteroid, Asteroid Watch is it's a challenge where people to have amateur astronomers make discoveries and basically create an open source network of quick response robotic telescopes to enable fast follow-up for potentially threatening asteroids. So they're trying to figure out what kind of size of telescope would be needed to be useful.
Well, I can give you my opinion. I think the minimum size would be 0.4 meters, but it all depends on what they want to do. If they're looking at characterization, so say taking light curves, for example, or spectra, you want it to be relatively big, but some of the brighter asteroids that are discovered each year, you can actually follow them up with something like a 3 or a 4 meter. If you want to do astrometry, for example, that's going to be a bit more difficult with a smaller telescope because the surveys use very large telescopes, 1 meter, even larger. So they discover very dim asteroids that you can't even see with amateur telescopes. So, okay, so the short answer would be 0.4 meters would be the minimum.
Thanks, Jose. Let's see, and the next question, I think this one's going to be for Dan, and it asks, so this is asking about the GMAP simulation, and is it possible to add an asteroid in for the simulation?
All right, so NASA's General Mission Analysis tool is very powerful, and it's oriented towards simulating spacecraft. So I think, you know, this simple approach would probably be to create an asteroid model, which is, you know, like a spacecraft without propulsion. And so, you know, you could, you know, put it into an orbit. You'd have your 3D model to represent the asteroid, and you just sort of set up the trajectory. And then, as far as say, you know, the create your own asteroid mission, then you could use GMAT to have your spacecraft that would go to that asteroid model. Now, if you're talking about, say, a distributed simulation, like in the you know, the asteroid simulators challenge, well, then something a little more ideal would be to have an external database like AstroRank or JPL's small bodies database there, and then, you know, exchange data between the simulator and that database.
Okay. And there are some NASA space mission simulators and game engines and asteroid databases that are listed on the challenge. Are there any additional ones beyond those listed?
Yeah, certainly. I've mentioned already Orbiter 2010. That's developed by Professor Martin Schreiber out of the UK, and it's got a large worldwide community. Celestia is another very powerful spaceflight simulator, and it's got a large user community. And then Analytical Graphics Incorporated, they offer a free version of System Toolkit 10, STK 10, and it's got a Java API. So all of those would certainly be good examples of spaceflight simulators, you know, for the Create Your Own Asteroid Mission Challenge, as well as the asteroid simulators, HLA interface challenge. And I can provide some links on the hackpad to those various spaceflight simulators.
Great, thanks. All right, we have a question from Jacob, and it says, this is for the Asteroid Prospector challenge, and the way, Phil mentioned that the weight of the asteroid is important, but is there a kind of size or shape of an asteroid that would make it more ideal for mining?
Not really. At this point, we're looking at bringing back a rather small asteroid to cislunar space, and it'll be so small there will be essentially no gravity, and therefore the mining equipment needs to provide its own reaction forces. One way to do that is to put a net around, or a bag around the asteroid, and then just hold on to the net, hold on to the bag while you're working on the asteroid. So that's for that reason, we really don't worry about the shape or the size. It's going to have to be small just because that's all you can bring back right now. But looking off in the more distant future, like this asteroid prospector game, we've imagined hopping through the solar system from space object to space object. And it would be convenient to have larger asteroids where you've got some gravity. It's always better to work in gravity. And there's some industrial processes that require gravity. Like, for example, if you're purifying metal and you're relying on density differences to sort out the different molten metals, you can get away without that if you have a spinning spacecraft to provide centrifugal force. So, but there are really only a few groups in the world that are looking into these issues. There are some asteroid mining companies, and they are pressing ahead, designing equipment, designing processes that will crunch up the asteroids, separate it into all different materials, create different material streams, and then begin doing manufacturing. And they plan to do all of that without any gravity at all. So it can be done. For that reason, I don't think the size of the shape really matters that much. I think the composition is the main thing. There are very big differences in asteroid composition. There are M-class, stony asteroids, carbonaceous, and that's the really big thing, because what you're going to be mining is determined by what the asteroid is made out of. I think that's the thing that really matters.
All right, thanks. And so, Sandy, we go to you. Could you talk maybe a little bit about when you're doing your detection of asteroids, how you try and what information you get in and how you try to determine this information?
For mining, we actually have a list of requests from our friends at Planetary Resources of asteroids to look at, which also overlaps a lot with potentially hazardous asteroids and whatever near-Earth asteroids come by closest to Earth. We try to really zap anything that's close enough and big enough to get us a good signal when it comes by Earth. And we can generally get a good estimate of size. If someone has a rotation rate, radar can get you a good estimate of size, as well as there's some we can't really determine alone with radar what something's made out of. Unless it's super shiny, then we know it's probably metallic or has a lot of hydrated minerals. But what you do is you combine radar data with optical data, light curve, to get size, and then you combine it with infrared data to get an idea of the composition. And it turns out that how asteroids reflect in radar really is tightly connected with what they look like in infrared with their taxonomic class. So are they metallic? Are they more rocky? Are they stony? Are they unprocessed at all? So there seem to be some connections there. But radar, you have to use other sorts of telescopes with radar to know more certainly what an asteroid is made of.
Okay, great, thanks. And Jose, at the Minor Planet Center, what do you guys do with where does the data that the astronomers collect go?
Well, we ingest thousands of observations each day, upwards of 20,000 on some good days or good nights, 200,000. And like I said, we don't receive the images, we just receive the actual data points of where the asteroids were in space or in the sky at a certain time. We ingest all these observations and we try to identify if they belong to known asteroids or if they belong to unknown asteroids. And because we're part of the International Astronomical Union, we have the authority to designate and announce new asteroids. And currently, observatories are discovering about 1,000 new near-Earth asteroids every year. And main belt asteroids that just discovered like about once every 20 minutes, main belt asteroids discovered. And we put all this together, we collect it in our database, and I should mention that this is a publicly available database, which is available to anybody with challenges. And we have a database of observations, but more importantly, we have a database of orbits, which is what we might be more interested in. And currently, we don't have an API. We do have a flat file, a big fat file with all the orbits of about 650,000 asteroids that are currently known in the solar system. We also have a smaller, more manageable file of about 10,500 near-Earth asteroids, which is probably what would be of more interest. So those have challenges. And I do have my database guys right now working on a database of physical characteristics of asteroids. And we hope that it's going to be ready by Saturday morning. And there will be an API of sorts so that people can query physical characteristics through URL and get back a JSON file. If anybody has more questions about this, they can send me a message or
Great, thank you. So the next question I think goes to Dan, and it says, 2 days seems like a very brief window to build an HLA-compatible RTI mission simulator. So maybe you could talk a little bit about just using HLI and where to get that kind of information.
All right. So I agree. The high-level architecture standard protocol is a lot to take in and try to produce something within a 2-day period. So the kinds of folks that I would imagine would pursue the asteroid simulators challenge would be folks that may already be working on HLA projects and may have already been working with some spaceflight simulators. When I look at the question, he also mentions the asteroid prospector, which I think Phil would be able to address that. And the idea there being with WebGL, developing a couple of simulations that use the the web graphics language. This would allow, say, the visualization to happen in a web browser. And by the fact that these would be two interacting simulations, they would certainly be good candidates for later implementing the high-level architecture protocol to allow those simulations to work over a distributed simulation federation. And I know that people do a search for the HLA standard, which is IEEE 1516-2010, and they go to the IEEE website. The IEEE wants to sell a copy of that standard. If the people pursuing this challenge are at a university, they should be able to find that IEEE 1516-2010 standard in their library, and therefore they could get it for free. So I guess I would turn it over to Phil to see if he's got any comments about the value of, say, a couple of interacting type simulations for the prospector.
Yeah, so I would say that the trade space is wide open. Anything you want to do on this is acceptable. And to give you an example, last year we had a game for our challenge. It was called Moonville, and one of the teams didn't even do a computer-based game. They created a board game, and the idea was that you could use a 3D printer to print out the game pieces and then play it. So yeah, I agree that 2 days is really challenging to try to build a game in that much time. You really have more than 2 days. There's 2 days for the weekend, but then you've got, Callie, it's like the rest of the week to finalize everything. Is that right?
They have, yes, they have until Thursday, April 17th, and that's when they need to submit a 30-second video, and this is all on the global judging page. And so the 30-second video, and then put any resources, a summary of their project would also be very good. So anything so basically the judges can see what work you guys have done for the Space Apps Challenge. And so whatever is on the website on April 17th is what's going to be captured for judging.
Yeah, and so we know that it's not going to, in that short amount of time, you're not going to create a fully mature game that's ready to go sell in GameStop. But we're thinking that this could be a good public affairs game that would help educate people about small bodies in the solar system and get people more interested in small bodies. We're not thinking it's going to be technically complete. It's not going to contain all the different aspects of asteroid mining or rendezvous of asteroids, but something that has value that would be educational would be great. And it could be anything that you want to contribute in that thing.
Yeah, and also there's nothing stopping you from continuing working on it after the April 17th. I mean, that's just a part of the Space Apps judging, which we want to encourage people to participate in. But this is going to be open source information, and you can continue working on your project afterwards, or even work off of other people's if somebody has something interesting to go. And then we also have a comment from Jerry, just that I mentioned that there is spacegambit.org, which is funding some short-term projects, and so this is just information from another participant, and so there might be continued funding through that. So that's it.
Callie,
Yeah.
this is Dan. I think if I may make a comment about that, I'm looking at the Space Gambit website there, and I noticed that one of the projects they have is the SAT-STAT-SIM. And that certainly looks like that would be definitely a good candidate to consider for maybe an asteroid, to create your own asteroid mission simulation challenge, as well as if it's got an API, perhaps someone could begin working on a high-level architecture protocol interface for SAT-STAT-SIM to enable it to fit into future distributed simulations. So I think there's a great opportunity there. And then I think they've already got a link to the Space Apps Challenge on the Space Gambit page, and so I think the space apps will certainly be sort of a rich area for them to mine when they're looking for future projects to fund.
Great, thanks for adding that. Let's see. So, yeah, and then we have a question also from Jerry about how many near-Earth objects are there that could supply fuel, and they're talking about water reaction masks and other materials for in-space use. So I think this goes back to something I think Phil addressed earlier about just how many near-Earth objects would have supply fuel that could potentially be used.
So I could address this one.
Oh, go ahead.
So I think as Phil was mentioning, carbonaceous asteroids are the best type because they have a lot of hydrated minerals, which is water and obviously carbon, so you can break up the water into hydrogen and oxygen. You can use the water as water itself, but also use it for fuel. And luckily, carbonaceous asteroids are the most common asteroids in the solar system, making up about 70% total numbers, which means that in the near-Earth object population, we probably have some 14,000 carbonaceous asteroids that are larger than 100 meters. So chances are good that if we find an asteroid that's easy to get to, that it's actually going to be a carbonaceous asteroid that would be useful for mining.
Thank you, Jose. Does anyone have anything else they want to add to that?
Well, let me add that there were people who talked about platinum group metals from asteroids, and maybe Jose could correct me on this, but I've read a couple papers that claim that, ironically, the LL chondrites are probably the highest concentration of platinum group metals. The L means low metal, and the second L means low iron. And, but despite that, they're supposedly very high in platinum group metals, according to the paper or two that I saw. So there are people who have published papers saying that they want to, for metals, they would like to mine an a stony LL chondrite. And also the paper said that there might be up to 20% water by mass, and you also develop a stony material, and you can 3D print a heat shield out of regolith. We've done that. We've tested heat shields that we've made out of regolith. And so the idea would be that you mine the asteroid, you get the platinum group metals, the rocky, the stony material gets made into a heat shield, and then the water gets made into propellants, and you can deorbit the whole thing, bring the metal back to Earth. And so there are people who think they can make a profit by doing that sort of thing. And I believe eventually that will be a profit, but people argue about if it is right now. Jose, is that anywhere near the truth?
I'm not a meteorite expert, but we probably read the same papers. Yes, it's as far as I know, that's how things stand right now. I think the problem is finding a large enough asteroid that it would actually make sense to bring it back, or bring the platinum group metals to Earth. Because even though they have high concentrations, it's all relatively high concentrations. So it's actually reasonably small. And I think you need, is it larger than 400 meters or something like that? An asteroid to actually make sense. All the money that you're spending to actually get there and mine this asteroid.
Yeah, right now it's not really economically feasible to go mine asteroids for platinum group elements. You're not going to be dropping the bottom out of the Chinese rare earth metal market anytime soon.
Oh.
Sorry. I know I just ruined your day, Jose. Will you forgive me?
No, thanks for bringing out the truth.
Well, so I tried to say that people argue about that, and I think that one day it will be profitable. Whether or not it is now is what people debate. And some of the factors that I haven't seen people take into account, usually when people criticize the idea of mining asteroids, they assume it's a one-off mission, that you launch everything you need to do the mining, you only mine one asteroid, and then you throw everything away. But companies like Planetary Resources, they plan on launching it once, then mining a lot of asteroids, so it spreads out the costs some. And like I mentioned, there are ways of reducing the costs by using the resources of the asteroid itself to fund the mission. So I have not seen their business plans. They say they have a business case, so I'm taking their word for it.
And I think this conversation really highlights the reason why we need asteroid mission simulations. Is to sort of try out these business cases with physics-based models and with the asteroid data to see how well the various concepts would play out, and to look at, say, traffic models. How many launches per year would you have in order to lower the price per launch down to a point that you could actually make a profit. So that's why we have these challenges.
That's great. We have one from Darko, and the question is, can you guys point out what are the key things we need to put more attention to on the Asteroid Cross-Voucher Challenge? I think this has to do with the fact that we made that challenge very wide open. And so if there are any key elements you thought, Phil, we might need you recommend focusing on?
Well, so I think the benefit of this challenge is to create something that's educational and fun, so people would play the game and learn. And so the question is, what are the things that you can communicate that are of educational value in a game like this? I think that talking about the different types of asteroids would be something that you can communicate. I think that talking about the different trajectories would be something of interest, the different types of near-Earth asteroids, and then the main-belt asteroids, maybe talk about some of the dynamic classes. Maybe talk about differences in size, I think those things would be easy to bite off. You can get the information easily, and you can build a game that includes those features. So you talk about these are the different classes of asteroids, these are the resources they have, and what can you do with those resources? Well, water you can use for propellants, use it for radiation shielding, and metal you can use it for construction, building spacecraft or building an outpost, and so on. Now, I think all that information is rather easy to get. Now, I would not probably, personally, I don't think I would put a lot of emphasis on the dynamics of doing rendezvous with these bodies, because the math is really tough, and I don't know that it's going to add that much fun value to a game to try to force the players to do this really complicated math that almost nobody can do. So I'm not sure that's a good way to write a game. Any other thoughts? Anybody else on the panel have ideas about that?
I think you're right, Phil, to focus on the sort of the fun factor first. I would say that there are some video game engines out there. Examples include the Unreal Tournament engine, and then the Unity 3D. They're out with version 5. And a lot of these video game graphics engines have physics libraries built into them. And so, if you do things like turn off the gravity, that you won't have everything fall to the floor, but you could still have inertia and other physics characteristics. And so some of the math can be handled by the video game engines and the physics libraries that are available out there. But I would agree as far as trying to worry about all the complex orbital trajectories. Again, I mentioned spaceflight simulators like Celestia, Orbiter 2010, STK-10, and NASA's General Mission Analysis Tool, GMAT. All of those have support for visualizing those complex trajectories.
Okay, great, thanks guys. And kind of in the same lines, we have a question about the visualize the asteroid skies, which is to create data aggregators and visualizations of asteroid data in meaningful ways to educate the public about the need to explore asteroids and protect the Earth from them. And so the question we have is, what information, beyond, Phil kind of covered a little bit of them, but what is the information that's really important to educate the public about that wouldn't be just fun to put in a game?
Right, so the Visualize the Asteroid Skies challenge there is to try to, give the general public a better understanding of how asteroids can affect their lives personally. Certainly, from the threat of a rogue asteroid. Phil mentioned earlier that trying to get across the concept of size. A lot of times people hear about, well, this thing's 10 meters across or 100 meters across, but I mean, how does how big is that? And I think if you were thinking about, say, a web app that might be embedded in a web page that would allow you to, say, select from a list of the near-Earth asteroids or the ones that could potentially come very close to Earth. And if you could click on those and then be able to somehow have a size comparison, maybe a football field or, say, the Empire State Building or something like that, and then, have a representation of the reference model that people understand or, can easily visualize, and then say, okay, this is how big this asteroid is. And that might be something that, might be kind of a fun thing to have in a web page where people can, just sort of click on various asteroids to see what their relative sizes are. Not to scare people, but I mean, one thing is how big are these things, say, compared to, say, a dinosaur killer, like the asteroid that hit 65 years ago, and how much of the world population would be affected by that. So those are the sort of the scary side of things. The asteroid database that's out there is not only a scientific database, but it's also an economic database where they've actually gone in and calculated what the value of some of these asteroids are in the trillions of dollars. So certainly, if there was a way to get across some of these business models of these companies that are planning asteroid mining capabilities, how would you present to the general public how this would affect the economy as far as maybe lowering the price of important materials?
Okay, great. Thank you. So we have a question about, do you want to add something?
Yeah, quickly. To go with what Dan said about size, and it's very difficult to visualize size when we're talking about asteroids, and also distances. And asteroids pass by Earth at what are, astronomically speaking, relatively small distances. So also having a way to compare the distances, the minimum distance at which an asteroid could come by Earth, I think that would be of interest. You could compare it, for example, to the average distance between the Earth and the Moon, which is something that we generally do in the asteroid world. And say an asteroid passes at 2 lunar distances or half a lunar distance. And even though the Moon is very far away, it's a bit difficult to gauge. If somebody tells you that an asteroid is passing halfway between you and the Moon, then you get a fair sense that it's a bit too close for comfort.
Does anyone have anything they'd like to add about what you'd like to educate the public about asteroids? Okay, we'll go to the next question, which is for Jose on asteroid watchers. And the question is, do you need a robotic telescope in order to attempt the challenge?
Well, I'm not actually the lead on the watchers, but I can attempt to answer that. From what I understood of the challenge, I think, well, is the question if they need to have a robotic telescope in order to participate in the challenge?
I think so. Yeah, I sorry, I misspoke with yours asteroid imagery. And yeah, I think that's what they're asking is if there's a way they could attempt the challenge without actually having a robotic telescope themselves.
So I think so. I don't know how many people have a robotic telescope just hanging out that they can use for a challenge. So the main challenge here is to write a program or some sort of interface or protocol for telescopes to communicate between each other, or for a central node to communicate and send instructions out to telescopes. So I think that can be done, yes, without having a telescope.
One of the questions mentioned the point network, which is distributed network doing voluntary computing, and it's setting is based off of that. So there are systems of software you can use to distribute computing and distribute processes across voluntary networks. So you don't have to write this all from scratch.
Okay, thanks. And just a reminder, you might be getting a little feedback, so if you're not speaking to mute, we'd appreciate that. Thank you, guys. And, let's see. And our next question, so yeah, we really appreciate it. We're getting lots of great ones. And this one, Sonia, might be for you again. Is the rotation of an asteroid, this is a scientific question, is its rotation related to its orbit around the sun?
Not necessarily.
Sonia, can you check your mic? You're getting some feedback in there. To make sure it's plugged in.
Is that better?
Yes, that's a lot better.
Okay, it turns out muting and unmuting it. Asteroids' orbits generally aren't connected to their rotation rates. Those are two different things. Like the moon, for instance, is tidally locked as it orbits around the Earth. So you only see the same side with the moon. And Mercury is in a weird resonance with the sun. It rotates 3 times or every 2 times it goes around the sun, something like that. I should know that. Some asteroids, though, their moons are actually tidally locked around the asteroids themselves, so that the asteroid can only see one face of the moon at all times. So there are cases where moons' orbits and rotation rates are related, but for the most part, asteroids, their rotation rates really depend on how they've been spun up by sunlight. So asteroids aren't symmetrical. They're lumpy. You can find an asteroid model to pull up. But they're not symmetrical, and so they're not symmetrical, they don't re-radiate sunlight uniformly. And so this causes the heat they give out to give them a little bit of a thermal torque, and for them to wobble and change their orbits. And also change the rotation rates. But depending on the size of the asteroid and how irregular it is, it'll change either the orbit or it'll change the rotation rate. So that's kind of cool. The benevolence of sunlight will do that.
Okay, thanks Matt and for Jose for having the model. And just you mentioned that asteroids have moons. Is there anything you want to mention about that?
About 15% of asteroids over 200 meters across have moons, which is actually really cool. Because when you observe an asteroid with a telescope, for the most part, you don't really have an idea of how big it is, what it's made. And so if you have a moon, you can get the asteroid's mass. So if you remember back to high school, Kepler's third law, if you know the orbit of something, you know the mass of the central object. So if you know what an asteroid has a moon and you can figure out the moon's orbit, you can figure out the mass of the asteroid. And you can use that to get the density and figure out, is this asteroid a solid lump or is it a pile of rubble? Is it just a gravitational aggregate is a flight term, but really just a bunch of gravel hanging out together. So if there's a moon, you can figure out all sorts of cool things about the asteroid. And then if you know that the moon is going to be passing in front of the asteroid and shadowing the asteroid, you can use that information to actually get some color maps of the surface, which is kind of a fun thing to do.
All right, great.
The asteroids and moons. I actually have an asteroid model. 1 second.
Okay. Let's say, and as well, Sandy is getting that. Our next question, because we're getting close to the end, we have lots of great questions. So I'm going to have one question for all of you guys. Up here, Sandy, with your asteroid model.
This is 1998 QE2. This was 3D printed by a buddy at the Propulsion Lab. And so this is about 3.2 kilometers across, and it's about as dense as water, which means if it's made of stone and rock, it's pretty porous. It's got all sorts of It's got holes in the center, so it's probably just a bunch of rubble. And then it's got its little moon, which is about 1/4 the diameter. And so this is about 800 meters across. And you can see that this moon's not quite a perfect little oval shape. It's got a little notch on the side. We initially thought it looks like a piece of candy corn. So it's kind of cool. Asteroids have moons. There's your factoid of the day.
All right. Well, thank you. So we're going to go through and have each person talk about, first of all, the question of, are there any interesting results you're looking forward to out of the Space Apps Challenge projects? Maybe Daniel first.
Okay. So the three challenges that I've got is the asteroid simulators challenge, which is probably the most difficult of the three. And my hope is that we'll find some folks who are familiar with the high-level architecture protocol, and that they will find some of these spaceflight simulators like Orbiter, Celestia, STK-10, and I saw somebody mention the Kerbal Space Program. So that would be a welcome addition as well. And then by having those HLA interfaces, it would enable NASA and universities to develop distributed simulations where we can draw upon the strengths of all of those spaceflight simulators. In the create your own asteroid mission, I would hope that people would grab any one of those spaceflight simulators, like NASA's General Mission Analysis Tool, or say the Kerbal Space Program and so on, and then create their own end-to-end spaceflight simulation of an asteroid mission. In some cases, like in the case of the Kerbal Space Program, you could build a launch vehicle and really kind of simulate what kind of spacecraft could you get into orbit. And others like Celestia or Orbiter 2010, you might show the spacecraft actually approaching an asteroid. Celestia would be great if it was, say, a robotics type mission. Orbiter 2010 would be great if you had humans in the spacecraft. And then finally, visualize the asteroid skies. As we mentioned earlier, we're looking at trying to present the data in some sort of graphical or visual format that will enable people to understand things like size and distance. And so I think there is a great opportunity to take advantage of, say, like the REST API. And then I noticed somebody mentioned Boink. I think Boink is actually a pretty good approach there. That's the basis of things like SETI at home. So instead of it being a web app embedded in a web page, in this case, this could almost be like a screensaver, where you would actually be pulling from asteroid databases, and that data would then come down to your machine, and then you could actually be generating visualizations on your computer.
All right. Thanks. Phil, do you want to go next?
Okay, sure. And I'm just going to go wild-eyed here on you and just talk what really makes me excited about space in my 1 minute. I just was reading something from a space policy expert, and he was trying to explain. He was trying to say, I understand why people don't get why we do space exploration. And the way he put it was this. It was a rhetorical question. Well, what is the question that space is the answer? And he was asking it like, it's not obvious that space is the answer to anything. And I just, oh my goodness, I can't believe a space policy expert would not get the big picture and would actually say something like that. So I am so excited because the big picture is that I'm sure this is the century that humanity is going to move beyond a single planet, because technology has gotten to the point where robotics and manufacturing technologies are mushrooming or exploding. And when we've got more robotics and we've got more automation in manufacturing, it's going to be almost impossible to keep people on planet Earth. We're going to put industry in space, industry is going to become self-sustaining in space, and we don't have to pay to launch everything. And once you start making everything in space, and you don't launch everything, then except the humans, then it opens up the solar system. And I'm utterly convinced this is the century it's going to happen. So I'm thinking that a game like this could be exciting because it can communicate that vision to help the policymakers, to help the children in school, to help everybody understand that space is the answer to a lot of questions, like how do we stop stressing our planet? How do we have the economic capacity to clean up the atmosphere? How do we make our place safe in the solar system? How do we go to other stars? You know, all of these things become possible when we get beyond a single planet and have suddenly millions or billions of times the resources that we have while we're stuck here on a single planet. So that's the big wild-eyed thing that I wanted to communicate. And I think a game like this could help to communicate that sort of big picture so that other people can get excited about it too.
Great, thanks so much. We'll go to Sandy next. So what are you excited about to come out of the asteroid challenges for space apps? Oops, I think you need to unmute.
This is my first year getting involved, so I'm super stoked to see what comes out of it and just what sort of projects get worked on, especially on some more of the asteroid observational side of things. It's great to, if there's anything that can be connected to the work we do here at Arecibo and sort of make people understand more how radar can tie into these things. That's great, but really just excited to see what comes out of the weekend hackathon.
Great, thanks. And we'll go to Jose.
So I'm still a bit emotional after Phil's speech, but I have to say that I agree wholeheartedly with everything he said. I think it's one of the biggest things. Asteroid-centric, I think the idea that we have now that we can move an asteroid is just simply amazing. For the first time, we're actually thinking of rearranging the solar system, which is going to be a huge step. If landing on the moon was a giant leap, I don't know, this is a ginormous hurdle jump. And what I'm expecting from the Space Apps Challenge is actually to be surprised. I think that's what these challenges can do. They can inspire people who generally don't think that they have anything to contribute to space or astronomy, people who are very intelligent, smart, very capable, and have other skills. And they can think in ways that, us old astronomers, in our old ways, we can't think. And they can come up with solutions that we've never come up with. So,
old astronomers, speak for yourself, Jose.
Yes, sorry, I meant everybody else, not something. So I really want to be surprised and see some lateral thinking and, sorry to use the term, thinking outside the box. And hopefully people will see these challenges and maybe not just concentrate on the individual challenge itself, but once they start working on that, have other ideas, and hopefully this will foster a longer interest, and they will keep working on whatever ideas they get.
I like to say that we need people to think outside the sphere of planet Earth.
Yeah. I'm going to steal that, Phil. I'm going to be using it.
All right, well, thank you guys so much for joining us. And we do have some questions that we just weren't able to get on. We had so many great questions throughout the time. And so we'll be putting those, some of them we'll be putting on the challenge, the hackpad that they're directed for. And then ones that are just asteroid in general, we'll create an asteroid hackpad, and we'll put a link to that on the Google page. But it'll be within the hackpads with all of the space apps. So, but I really want to thank our whole panel. I really appreciate everything. I'm actually not an asteroid expert. I work for the Launch Services Program here at Kennedy, but I do work on launching missions that go to asteroids. Like I worked did some analysis for the Dawn mission, which was in 2007, and coworkers worked on OSIRIS-REx. So you guys are very inspiring to me, just to hear the science behind the spacecraft that I'm working on the launch for. So, and with that, I think we'll say goodbye, and we look forward to working with everyone this weekend. And also, if you have an interest in an asteroid, we're also the Asteroid Prospector. we'll be having another Google Hangout specifically for that challenge on Saturday. It will be at 2:30 p.m. Eastern. And so, but all that information is going to be on, again, the Space Apps KSC webpage. So thank you guys so much for tuning in, and I'll see you later.
Thank you for that.
Yeah. Smells good. Where you are? Next up. No.
Hi, my name is Callie Burke. I'm here at Kennedy Space Center for the Space Apps Challenge. And so we're going to be talking today about one of the Kennedy Space Center challenges, Asteroid Prospector. And so I just want some fun props. So we have people here, in addition to hosting 3 out of the 45 Kennedy Space Center, 3 out of the 45 Space Apps Challenge, we're also in location. And here's our Yuri's name too. And one thing that's important to know about all 3 of the Kennedy Space Center challenges is even if your project isn't nominated for global judging by your location, you can still be eligible for the Kennedy Space Center. We're doing competition too. So we are also going to be offering for launch viewing opportunities for the winning teams. For each of our 3 challenges, we'll have KSC judges they're going to be experts in the fields related to those challenges. We'll be looking at the projects, so we'll be looking at the 30-second videos that we submit by April 17th. That's this Thursday. And we'll be looking at the data, that the descriptions that are on the project pages, and also looking at the whatever resources you put down. So I know we're really looking forward to seeing what people come up with. And we did this also last year, and so we had people come through Neighbor Watch. And so that was lots of fun. I got to meet, our team got to meet people from all over the world that came from Finland and Greece and England and Italy and Mexico. So we had a blast. So we really look forward to meeting the winning teams, which will each select 2 team members to be invited guests, and then those 2 team members will each have one additional guest they'll have can come out and be a invited guest. There's more information on our Tumblr page. So now I will introduce Jim, who's going to be going answering your questions today. Jim? I don't think we have any verified, so just speak loudly.
Okay. I'm a physicist at Kennedy Space Center. I work in granular mechanics, the operations lab, and Phil Metzger is the lead of the lab. And he worked the Space Apps last year. He couldn't be here this year, so I'm filling in for him. And I'll be one of the subject matter experts in regard to this asteroid prospector space app.
Okay. And then the other thing to note is that, so we're going to be looking for questions using the hashtag Asteroid Prospector. But also we're going to have the question and answer part of the Google Hangout enabled. So you'll be able to see questions coming in, ask questions coming in there. And so we'll already go to our first one. And so this is from Ross. And so he's asking, which challenges are planetary resources or deep space initiatives or NASA? So these are a couple different organizations. What are the challenges they're trying to brainstorm and solve? And so they have scope creep, and they don't want to solve problems that have already been solved.
So they're looking for novel problems?
And let me open up the question. Just give us a second while see what had it. So Jim can see the questions here. There you go. Yeah, so that's the question we're asking right now.
Well, one of the unknowns right now has to do with
Go for what I like.
what materials are on asteroids. The only information we have right now is from the meteorites that struck the Earth and trimmed on the Earth.
Peter,
Those
wait,
are
have a
fragments that
massive
came from
challenge.
asteroids
Sorry, Chalice.
that have been floating around.
I'm sorry, Chalice.
told you.
So we have an idea that there are
Would you like coffee?
metals,
What kind of coffee?
various
Yeah, I would, but
minerals
I could give you some extra money.
that
No.
asteroids are composed of.
What is it? What do you like?
We're going to go to an actual asteroid. The biggest challenge right now is to
Whoa,
know
that's
ahead
high.
what resources are on a particular asteroid, a target asteroid. Because you don't want to spend talent or money to go to an asteroid that doesn't contain the resources that you're looking for. So one way, some of the ways that you can try to determine what's on an asteroid involves using large telescopes and doing optical spectroscopy. And that's a technique that relies on light from the sun that scatters off an asteroid. The telescope can collect that light, process it through, you think of like a prism that breaks up light into different wavelengths, and then you can look at those different wavelengths and see, look for signals that correspond to particular types of materials. Water have a distinctive spectrum or spectra that will be different from, say, platinum. And so, if you're developing an app, it would be useful to know by this remote sensing what kinds of materials are on the asteroid that you're going to explore. So I would say that would be one challenge that we want to look at. Another challenge has to do with the distance between asteroids and the Earth. If you're going to control your asteroid prospector remotely from Earth, then you have a communications issue as well. Depending on if you're just communicating with Mars, for example, Mars and the Earth are at their closest distance from each other. It takes about 4 or 5 minutes for signals to go from the Earth to Mars. And when they're on opposite sides of the Sun, it can take 20 minutes. And so asteroids are beyond Mars, so you can imagine there's communications issues that you also have to deal with. So your asteroid prospector ideally would be autonomous. It could make decisions on its own. So that would be another problem. If you can solve that problem, that would be very useful. Then you're not relying on Earth to direct the prospector. Those are ideas.
Okay. And we have a couple coming in from Twitter, and so we have, let's see, Spot the Station AUT is asking, they're asking for ideas for the end objective. So we've got a couple people that may be associated with the same team. Because if we go to our page, we put a couple different goals. So maybe you could talk about some of the objectives that they might choose for the game.
Yes. So this is on the description page.
Yeah, well, that's where we've listed a couple, but just talk about kind of some of the different things, the end objective for the game. I mean, because one thing that, we wanted this to be wide open, so, I mean, part of it is we want people to actually be choosing what they go for. But maybe you can talk about just some of the different ideas. Scroll up. Okay. Yeah, these are all ones.
Yeah.
And there's some at the top, there's a list of objectives.
There's a lot of things you could consider. When you're going to asteroids, you're going to have to be self-reliant for the most part. So you might consider what happens if you run out of power. What are you going to do? You don't want to be stranded out in the asteroid. So you want to look for asteroids that might have water ice, for example, and convert the water, extract oxygen out of the water and hydrogen and use the hydrogen and oxygen as fuel. So you might want to consider periodically resupplying spacecraft.
But they might
So you might go to one asteroid
because
to do fuel, and then go to other asteroids to do mining. So materials that are interesting,
but then from those teams they'll cull and choose a
materials like
subset.
platinum
And every single site
are very valuable.
3 projects that they're putting forward. And then
Materials that find Earth, so that's why they're
choose from those the one
and
they go
you might seek out asteroids that have this
they
value.
go to the final stage that would be
Keeping in mind that you need to
nominations.
resupply.
And I think at
Some people think that
no, I
you use
think
solar
they'll get another
electric
chance to
propulsion
do
methods.
another video.
Um,
Because otherwise
And
they'll
we
have
have used those
3 by how many
send
sites
spacecraft
of people,
on missions
like different projects.
to asteroids,
Yeah,
but they're not intended to collect material. Bring back to Earth. And so while they're very fuel efficient, they don't have
I think they're doing another video
large quantities
so
of
if they can
material.
explain it a bit more.
So it's
Bit more
really,
because then it's the same as they had last
if you
year.
want to bring back materials from asteroids and
Last
these
year,
elements that give us
the teams,
that have a lot of energy.
what they had them all, then they developed the videos.
Another consideration is
the general public could go and watch the videos.
maybe for this challenge,
Like them or send tweets to
That's
or have
too much.
I think they did it on Twitter that they.
And the time frame we have, it is hard. Okay, great. And so we have another question via the Q&A. What would the finished game be used for?
That's all right.
Jacob.
Okay.
well, what we'd like to do at NASA is have these, use these competitions to, as a springboard for bring up novel solutions. And so we're hoping that to look at all the solutions that you can come up with. And they're all going to be interesting solutions and fun to develop. And we're looking for some that may be feasible as far as today's technology goes. So connecting to technologies that are available today would be very helpful.
Go back to, thank you for that. And so, yeah, in addition, you can ask questions via hashtag Asteroid Prospector. Maybe you want to show a little bit of your the presentation you gave here at Kennedy this morning about asteroids and space mining.
Yeah. This is this background gives us an idea of what asteroids, why we want to visit asteroids. So my first slide, I'm showing why we might want to bring the asteroid back. It's usually, if we're interested in testing new technologies, whether it's solar electric propulsion or human spacecraft like the Orion capsule or various launch systems, it might be easier to bring an asteroid, capture an asteroid, bring it back to near Earth orbit, and test those technologies closer to Earth rather than at these where the asteroid originally was. Another aspect is that we can do a lot of interesting planetary science. Asteroids tell us the history of the solar system, basically. It's a time capsule. And so going to an asteroid and finding out what it's made out of tell us something about the origin of the solar system. Asteroids have the potential to wreak havoc on Earth if they collide with the Earth, depending on the size of the asteroid. So we are interested also in planetary defense methods to save humanity and at least to protect large populated regions under it. And then finally, there's the mining and manufacturing in space. If we're going to become a spacefaring civilization, we need to be able to utilize the resources that are out there in the solar system. And the asteroid belt contain a lot of very useful, very valuable resources that will enable the exploration of the solar system. So those are motivations, some of our motivations to asteroids. This graphic illustrates an asteroid capture concept from the Keck Institute of Space Studies. And it's a giant bag that they bring the spacecraft. You have to match, your spacecraft has to match the orbit trajectory of the asteroid. So one of the challenges is getting that spacecraft to almost dock with an asteroid, and then you can interact with it, you can capture it, or you can start to mine it. And so this concept shows a bag that seems to capture the asteroid. I mentioned trajectories. Well, one of the big challenges is if you were to simulate going to an asteroid, we have to consider the Earth is the location where the spacecraft launches from. So how do you get from the Earth to the asteroid? You have to predict where that asteroid is going to be sometime in the future. And you have to fire shoot the spacecraft directed in such a way that it intersects with the asteroid at some point in the future. So that requires orbital mechanics. Again, that's for this space app challenge. That's probably too much. You don't need to worry about that. And plus, trajectories are very complicated because there's interactions between the Earth, the Moon, other planets, as well as the Sun that you have to consider. So manned spacecraft, if you were to take astronauts and want to send them to an asteroid, they're going to have to withstand radiation effects of deep space. And that's an unknown. So we're doing it right now on Earth. Test field sites like the deep space habitat where astronauts can live for long durations in an isolated habitat. They kind of simulate the isolation of being out in deep space. And then this is what we're trying to prevent, asteroids from colliding with the Earth and causing destruction. The National Academy of Sciences in the U.S. has looked at potential problems associated with asteroids and considered what kinds of actions to take for sort of events. How can we prevent the asteroid from striking the Earth? We might be able to push it out of the way, out of its original trajectory. We can pull it. We can have kinetic impacts which disrupt the trajectory of the initial orbit of the asteroid. Nuclear explosions could fragment the asteroid into pieces that go in different directions that might avoid colliding with the Earth. If we don't do any of these things, there's a potential that humans could go extinct. And depending on the size of the asteroid, that will kind of dictate how much warning and where it might or when it might interact with the Earth will dictate how much warning time you might have. So if you want to, if we can predict that a particular size asteroid is going to potentially collide with the Earth at some point in the future, that's going to be our warning time. And based on that warning time, we can look at these various methods of mitigating the hazards associated with an impact by an asteroid. in terms of the size of the asteroid, and if it's a large asteroid, maybe we need to consider nuclear explosions. If it's smaller in size, we can consider less drastic methods of redirecting the asteroid. This slide just shows it shows what kinds of civilizations, how you can characterize civilizations. Right now, the Earth is a type 1 type of civilization that uses the energy of the entire planet. If we were able to utilize the sun's energy, we would be a type 2 civilization. If we could use the energy of the entire galaxy, we would be a type 3 civilization. So here we are right now, it's a type 1, so on. But where were we before we became a type 1 civilization? Well, before, we could only explore continents. And, we had sailing ships to go from one continent to another. That is described as a type 0 civilization. Type -1 civilization would be one that would normally explore, say, a river. The type -2 is just local surroundings. We never venture beyond our local environment. That's a type -2. And so we don't have really a resource problem. We have an imagination problem when it comes to space exploration. There really are an infinite supply of resources in the solar system, in the asteroid belt, the planets, just waiting for us to utilize these resources. That's a benefit to us on Earth, where we don't have to, we may not have to use these resources on Earth. We can supplement them with resources we find in space. And I'm going to go on to this slide, which shows how we can profit in space by going to asteroids. So we're supporting, by going to asteroids, we're supporting exploration of space and also planetary science efforts to understand how the solar system is developed over time. There's the potential for space tourism and other novelties, bringing materials back to Earth, artifacts like that. And manufacturing. In space, manufacturing in space is going to be very different from manufacturing on Earth. If you think about it, say if you wanted to do manufacturing on the moon, well, there's no atmosphere on the moon. There's no running water, so a manufacturing plant requires fluids that can help with dissipating excess heat. How would you do that on the moon? How would you do that on an asteroid? So there are challenges to manufacturing that need to be challenges that need to be considered and overcome before we can do manufacturing in space. But if we want to explore space, we really have to manufacture. That's another way to become self-sufficient. Planetary defense is another way we can profit by going into space. Tracking asteroids from the Earth is done with telescopes. We can send spacecraft out into the solar system and discover asteroids that you can't detect because they're so small. You can't detect small satellites from Earth-based telescopes if they're not big enough to reflect light from the sun. So sending spacecraft out is one way to track and discover new asteroids. We can, by going out into space, we can take advantage of solar radiation and possibly beam some of that solar power back to Earth and solve some of the energy needs on the Earth that way. And then material resources. For mining, there's metals, valuable metals like platinum that can be found in asteroids. Helium-3 is believed to be available on planetary bodies like the moon, and that would be a very valuable resource to mine or excavate from readily from planetary soil, if you can detect it and capture it. And then finally, there's support for communication and navigation satellites. We know about communication satellites around the Earth. Well, imagine setting up colonies in space, and you need a much larger communication system to do that, to travel into the solar system. So that's going to be another challenge in navigating.
Hi, my name is Callie Burke. I'm here at Kennedy Space Center, and we've been talking about the different, having Google Hangouts for each of our 3 different Kennedy Space Center challenges that we've developed that we're having people worldwide work on. I'm really excited. You've seen some of the teams have been already reporting different things. So we're going to talk about space wearables for this Hangout. And so one thing we have is actually fun. It's a local challenge, and so this is our location. We have people working on stuff in addition to hosting challenges. And this is one of the ones where we're going to be having launch human opportunity prizes for the winners worldwide in these 3 challenges. So if you work on the Space Wearables project, if you're nominated for global judging, you can put up a 30-second video and the summary and put all your resources and go into global judging. Well, additionally, even if you're not nominated for global judging, you can still, for Space Wearables, be judged by the Kennedy Space Center judges. And so do the exact same things by April 17th. Fill out the 30-second video and put all your information on there, and we'll have our local teams here look at those challenges. And I'll show you guys, we had something last year for our 3 Kennedy challenges for the NATO launch. So this is the signatures from them. And so we had people from all over the world who came and viewed, and so the winning teams will get to have 2 guests, or 2 of their team members be NASA invited guests, and then each of those team members will get 1 additional. And so I will turn it over to David to go ahead and talk about the Space Wearables Challenge.
Okay, hi, I'm David Miranda. I created this challenge because I had a big interest in wearables and how we can apply this technology here at NASA and specifically Kennedy Space Center. What this challenge is all about is it's for both designing a wearable for an astronaut in space in either the International Space Station or a future mission to an asteroid, all that stuff, or here at Kennedy Space Center, we have a lot of ground technicians who do a lot of work setting up a rocket, integrating all the pieces, and I think there's value in wearable technology there as well. So that's what this challenge is about. Develop technology.
No, but this one, you're good.
Develop a technology that, a wearable technology that you can wear in glasses, wear it on your watch, or something else. We're really looking for innovative ideas that can help people in space and on Earth help with the space exploration mission.
So do you guys each want to introduce yourselves?
Okay, I'm Nick Kendrick. I guess I'm just the smart matter expert on ground processing for space vehicles. I've been part of the processing team at Kennedy Space Center for going to be 30 years next year. And then you're at the space shuttle as a technician, as an engineer, as a project manager, and currently working on the Orion program. which is the next space capsule that will take me into space.
So my name is Joshua Manning, and I'm a NASA software engineer with the Ground Systems Development and Operations Program, which is our current follow-on program to the shuttle that will be processing the large NASA rocket that we call the Space Launch System, or SLS, you may have heard, as well as the Orion vehicle, which we also call the MPCV, or the Multi-Purpose Crew Vehicle, and those are used interchangeably. And what I do is I work on large software systems, primarily in the area of work control. So this is something that I've been interested in. We've historically used a lot of paper systems to do our we call flow processing. I think the Nick talked a little bit more to it in that, and we're evolving toward more technology adoption. So we've gone, over the years, using computers more and more, but a computer is a bulky piece of hardware that you can carry around with you. Sometimes you're doing sensitive operations or complex operations. You may not want to have that kind of hardware near the facility. In the facility, you may not want to be, carrying that around with you. Even a tablet is still something that you have to manage with your hands. So we kind of saw wearables and emerging technology with things like Google Glass as a displays and watches as an opportunity to maybe provide additional information during these during processing where our technicians and our engineers can be quote unquote hands free, or they can even be inputs to a stream back to a control room, if you will, or another group where they're monitoring progress. So we see there's a lot of potential applications for wearable technology. It's such a rapidly changing market that it's just a domain that we want to investigate a little bit more. But I think the challenge itself is interesting in the idea of embedding computing into astronaut clothing or devices that they would wear, and having all that information on hand, readily in context as we perform our functions in our jobs. So.
And as you already heard, I'm David Miranda. I work at Canadian Space Center. I work for the IT director, specifically part of the IT director that does a lot of research into new technology areas. And so the work I've done in the past has been a lot of modeling simulation, specifically discrete event simulation. But more recently, I've moved into the area of more software development, looking at technologies and seeing how we can apply them here at work at NASA. So we've looked at things like 3D printing, we've looked at a lot of touch technologies, like touch tables, tablets. And so this new area that we're very interested in is the wearable technologies, because GSDO is a program at the Kennedy Space Center, and as the IT director is a supporting organization, we want to develop applications and software and hardware that can support our programs. And so we're looking at wearable technologies for all the reasons that Josh mentioned. So, and that's why I created this challenge, because we have ideas, but we really want the world's ideas on how to make these challenges work. Actually, the program director of GSDO was here today at Kennedy Space Center to introduce the Space Apps Challenge, and he called it our annual Get the World to Work for us for Free event. And so, thank you for working on this challenge, and we're definitely going to look into your ideas and potentially use them here at Kennedy Space Center and maybe other centers. I know Buddhists have work as well, especially in the realm of wearables. I'm sure we'd be interested in the results that come out of this particular challenge.
And great. And so I just wanted to reiterate that we can take questions either on Twitter using the hashtag #SpaceWearables, or we have a question and answer portion of the Google Hangout. So if you guys want to post them there. But switch back over to you guys. And so one question I have is, so you mentioned a couple things you guys have looked into, but what are some projects that you guys are aware of here, being in the Spaceport Innovators group, of new technologies that Kennedy's has already taken advantage of? Or just, things that we're working on, like if the Swampworks is taking part of visualization that you do.
Right, so I guess it's a variety of technology. One of the groups I work in, we do a lot of visualizations of ground processing hardware. So just go to the YouTube page for NASA Kennedy, you'll see a video of ground processing for the SLS rocket for Kennedy Space Center. And I mean, there's been a lot of work done at the SEO program that is showing you every step that goes along the way to process this gigantic rocket, this new Saturn V scale rocket. So there's been a lot of work in virtually building this world and making sure that everything works in the virtual world, so that when they build in the real world, we do it right the first time. Sort of stuff we've seen in space that anybody
Well, maybe we could do a little plug on space for innovators. Sure. You can also some background information. So our day job, we kind of give a background of our day job. We're passionate about trying to understand more or less how to make our jobs and our work more innovative. That can be a job with the best breed of technology or even just ways of thinking and try to apply it in the context of ground systems for NASA. And so a few years ago, David, you run it, I think it's here. It was still about 4 or 5 years ago. We started a group called the Spaceport Innovators, and that's essentially we're chartered with trying to coordinate, organize events at the center and get folks engaged and involved and aware of sort of the innovative practices out in the industry and on center. So we try to meet pretty regularly to just discuss things like, new technology that emerges. Is there, can we apply it to something that we do out here? We look at both literature and hardware and software, so it's a pretty broad range of things that we try to get our arms around. So that's a little bit of background on that. We do that kind of in our free time. That's kind of what we want to do is sort of prompt us into a lot of these sort of engagements and discussions. We do get access to a lot of exciting and interesting things in the center. I think the SwampWorks lab is a pretty good estimate of innovative thinking applied at Kennedy. And so they deal mostly in technologies related to regolith or lunar or Martian soil. They have a lot of engineering applications that think of specific to this topic. If we come across any mobile or wearable technology that's being used currently at KSC, we know there's a group, the office of the CIO, the Chief Information Officer. They have an IT labs function where they see sort of early projects that may have a lot of application to our industry, and one of them recently was specifically for Google Glass, right?
Actually, for wearable.
Oh, was it? Okay.
Specific Google Glass.
And so I'm aware of that, but that's in its early stages, so I'm not sure how mature that project is.
I believe it was starting out, and it's actually an agency-wide team. You have the Kennedy Space Center, but also from another center that are working together on this particular challenge. So there's also been research in the past in this area. I know in the early 2000s, 2001, I believe, and 2004, there were studies done at Kennedy Space Center and at Goddard, where they looked at space wearables. But even 2001, 2004 is not that long ago. It's actually centuries away in terms of technology, at least in this area of technology. Because back then the wearables were very bulky things. They were heavy to use, very big. In fact, they talked about the Goddard study. They mentioned the fact that the wearable was too big to fit under one of those bunny suits that we wear in the clean room. It was too big. And nowadays, our wearables are, like, you can mistake my watch for a wearable right now, or my glasses for a wearable. It's that small. So there's been leaps and bounds in technology. That's about all I know in the area that's being done nowadays.
One program that I know that kind of was going on for a while, they started the House Space Lab. It's called and something like that was they outfitted people. They actually got from the movies. They outfitted people out with, and they used these different cameras that they captured. They could put them in a simulated situation and turn them into a computer model. And by using those computer models, they could tell like the stress how much weight that the person was.
So motion capture?
Yeah, motion capture it was, and that it was really good because we could set up operations that we didn't have to, and then give them boxes that we thought like components away. It was got away from some back. It was really good at this model and calculation.
And actually, that would be an interesting application to for a space wearable, because that's a lot of basically faking it and then doing studies on that. It would be interesting to get something that could measure that type of data live and feed that back to technicians or doctors, and say you're lifting too much, or this astronaut, that big boulder we were picking up on Mars is going to kill you.
Yeah, you model it. It's awesome.
Yeah, I know. I always find it interesting when I work things, and I'm a trajectory analyst, but they'll sometimes show us they just do the ergonomics, and so they make sure that the technicians of certain heights can actually fit into it. So sometimes when you're processing spacecraft and launch vehicles, there are some really tight spaces, and you have to worry about a lot of things and whether or not you can actually reach the part you're getting to. So. Well, why don't we have Nick actually give us maybe ground processing 101?
Okay. First of all, I guess the difference kind of with the new program versus shuttle was we're actually a little more similar here than what shuttle did. So in the ONC building, we're actually manufacturing, putting together the capsule for Orion. So there's a lot more going on than what we had in the shuttle. So we assemble the crew module, which is a little cone looking thing like the Apollo capsule. We assemble that on top of the service module, which provides all the commodities and stuff for space once they get out and the astronauts are floating around. So we put that together on the ONC. We do detailed checkout, all the crew systems, the checks, and we push that out into another building where the operator contract takes over and we service the vehicle. So we load gaseous oxygen and nitrogen for breathing. We load the propellants that use when the space vehicle gets in space. You have to steer around. It's a different situation. You have to go jets that require fuel to push them around, and that's nitrogen tetroxide and hydrazine. So we'll use that to steer it around. So those got to be loaded. They're very toxic, and you have to load those in special suits. Then we load ammonia, which is very pure ammonia. It's very hazardous. Also, the pressurized stuff. The high pressure is like 6,000 psi. So we do all that stuff in another building. In the meantime, in parallel, the rockets, and that's the solid rocket boosters are being built up. We have it's called the core, which is a huge tank that holds hydrogen and oxygen. They assemble all that together, and they get it ready for the Orion spacecraft, which is the spacecraft of the astronauts. And they do all that assembly in the big VAV building. If you're ever here in Florida, you come down and visit the space center, you need to go out and see it's a huge building on big building. So they'll assemble all that together. They'll do the final test, they'll do the integrated test, make sure the whole rocket capsule all talk to each other and fit together, and then they'll roll out to the launch pad. And for this program, it'll be I think about a 5 to 7 day stay. We're going to launch countdown and shoot it up.
Okay. And I liked how you were talking about the vehicle assembly building. There's a great picture of it right behind you. Telling you just how high the doors are. So it's quite the building, Statue of Liberty inside. You don't? Okay, see, I didn't have that factor. I knew the height was there. It's only, I think the Statue of Liberty is only around 316 or so feet. Actually, that's not a big boat. Okay, well, we have a question. Okay, from Alessandra Zoni, who actually, he worked on our deployable greenhouse from last year, so he came out for the Maven launch. It's asking, do you have any strategies for to preventing osteoporosis and muscle stiffening in space? And so it's probably thinking about how there's exoskeleton suit solutions and how that might help. So.
Well, that's not my area of expertise, but I know they are looking at resistance bands and stuff like that, because you don't have gravity. I know a lot of it has to do with, they have treadmill, shuttle, I know in space, these treadmills where they have elastic straps that kept them held in. But I think think, one of the things I'll look at is suits that actually have restraints in, so that you can continuously have restraints on muscle. But that doesn't help your heart. I think one of the big things that they have, the issue is, that after a while, one of the limiting factors is your heart, because it doesn't have gravity. Starts to, I don't know, for
Active muscle atrophy.
Right. So you get atrophy. So that's kind of a tricky one that I don't think they've quite figured out. They'll have to figure that out. Implant or something. Something that you put your heart rate up, on a regular basis.
Well, that's one thing, and maybe where wearables would tie in is that as they develop these exoskeleton suits, maybe they don't just provide resistance, but they tell you what that resistance is.
Right.
And so you embed it into it.
This is the almost, it is fully outside of my area of expertise, but it's a fun thought exercise, I think. I don't know if this, it would be so much not in the like an EVA or extra vehicular activity as much as that it would be during, if it was a long duration mission where you're just waiting, 8.5 months to get to your destination. You may want to have some kind of a suit that can either maybe monitor muscle fatigue or wear atrophy, or maybe it is just a large body band. So as you're doing small movements, it's creating that effect. So it's interesting. It's something I hadn't really thought of in the context of the paradigm of wearables before today, but I can definitely see where you could have a suit embedded with that kind of feedback information and have it giving intelligence. Maybe you're not working your left leg as much as the rest of your body, and if you've gone a right step, and it can help you adjust just movements. I'm sure there are folks looking into it. It'd be interesting to see if there's current military applications and if there's one exoskeleton research there from a owl perspective. So.
Yeah, and I know that's a good question. I know our astronauts have a hard enough, we on Earth have a hard enough time dealing with our own ergonomics, let alone you go up in space and it all changes. So, and Alessandro joined us from Rome, Italy, and we actually are excited we have a team here at KXC that's working on space wearables, and one of our participants happens to be in town from Italy, so that's great. So another question is how many people regularly would work on this? So I'm gonna backtrack just a minute. So Nick, you've been talking about how we do ground processing we're looking for at the GSDO, but there's also ground processing that our commercial partners are doing. So what's the connection between Kennedy's ground processing and the commercial partners who do that work?
Out of our office, we do all the commercial, and I think the thing with commercial is we kind of want to try to stay out of the business as much as possible, let them come up with commercial solutions rather than, NASA's always been so proactive inside the contractors for selling stuff. So I kind of think an approach where we're kind of hanging back, letting them kind of come up with their best practices from commercial and being advisors to them and kind of monitor them. Of course, the funds are provided. Right now there's still competition going amongst who's going to take the space station. But kind of the approach is let's just see kind of what they come up with, and as long as they stay within the guidelines of safety and stuff like that for the astronauts, and we're going to kind of let them tell us.
And so I'm a little biased. I work for the Launch Services Program, which currently has launches going on, and we work with companies such as United Launch Alliance, Orbital Sciences, and SpaceX. And so we do have engineers who go and they observe the ground processing and use for our missions. But again, they let the contractors, as long as the contractors are doing the appropriate work, we don't direct them how to do it. We just make sure that the proper work is occurring. And it's the processes that they've set up in their company and agreed to. So, but so next question on the back is how many people does it take to process a rocket or a spacecraft?
When I was on the space shuttle, we had a lot of people. It took a lot of people in very complicated spacecraft. After the space shuttle shut down, the operator contract, I believe, don't even like cooking this, but I think it's like around 1,500 people. Which includes the engineers, technicians, and all the support people that are required to do that. So, and again, that would include the rocket assembly, rocket checkout, and the core piece, which is the cryogenic section that makes the main engine go, and also the Orion capsule, which is the process, and that's after the Orion put together. So that would be all the servicing, assembly of the rocket.
And how many different types of jobs do people have on a shuttle? You had all those people, but how many different kinds of roles were they filling?
Gosh, you can't imagine. I started out in aircraft. Aircraft was my first thing at school. I worked as a pilot, and I was a flight line technician. And when I interviewed for the job out here, it was literally a 3-month period. And we did everything. We checked it out. We filmed the shot. We did all that stuff. So I thought when I was interviewing for the job for the show, I thought, man, this is going to be a tough job. I'm thinking we're going to be like 5 of us. We're going to be out here. And I'm going to have to do everything on the space shuttle. And I get out there, and it's just a swarm of people. There's probably 200 to 300 people just working on the shuttle, just in the processing facility. And there's everything from the thermal systems, which is the tile, to fluid. You have specialists in every system. And you have to really get to know them to the ultimate detail of all this stuff, because you run into stuff spatially, it's complicated. It's a very unforgiving environment. Trend problems, you run into trends and things. And you have to continue to be honest. Every one of these systems have, like hyperball systems like that. We'll have one whole team of specialists, and those specialists will go across the country. Right now we're talking European, USA, we're talking about White Sand, people in Glen Research Center. So each system has a very dedicated team of very highly specialized.
It's interesting. You mentioned we look at trends and try to pull a lot of data. So kind of pulling back to the theme a little bit. One of the areas we thought that may be an interesting application for these microprocessors and wearable devices in the context of ground processing is these vital signs, collecting data, exposure to things like hyperballs and other hazardous gases over time. We have a contractor out here that collects that data, and they have sensors that they'll send out in the field, and you'll have to wear them separately. It's not part of the uniform, if you will, of a technician or an engineer out working in the facilities out here. And many encompass the level of asbestos, if you will. But so there's those are the kinds of applications we're thinking here as really as a data collector and a source of input is in collecting that data, doing trend analysis to make sure that folks are safe. And applying that all the way across the spectrum from this, we can protect, we can advance and sort of perfect that kind of technology here on Earth, but then trying to kind of is that then evolving that to something that would be useful for astronauts when they're processing, turning wrenches, on the lunar Martian surface in 15-20 years. So,
yeah, there's for instance, I know the shuttle, or the technicians that are working on processing, so I think hydrogen is like 6.5%. So the exposure levels are like we try to protect for 10 parts per billion. And these guys are out working around it, knowing what they've been exposed to. Sometimes if you have a leak or something, if the suits have detection that can record what they've been exposed to and stuff, that data is would be very valuable to have, because for instance, hydrogen is a cancer causing mold and predict accumulates. So having that type of data on people would be very good. Safety is one of the highest priority. We have an excellent safety record of space, and considering all the hazardous operations that we can do, our accident rate is very, very, very low. So it's to us, it's the utmost importance process.
I just have to, when you talk about the dangers of hydrazine, if anyone's seen the movie Europe Report, the substance that the astronaut got on him that they had concerns with him bringing it into their space vehicle with hydrazine. So, we have a question from another one from Alessandro, and it's about the extravehicular mobility unit. And he has some detailed questions, but I wanted to just check before I even mention this if any of you guys are really very informed on that, because I think that's really a Johnson project. But do you have some? Oh, okay.
This is the unit that shuttle had, I believe that, I think in Bradley, it shows the guy out.
George Clooney, yeah. Yeah, I think so. And so we'll try it. Let's see. So he had questions about the gloves, and if you're aware of any of the main issues that have with those gloves.
And then I know gloves in particular, I used to work with a polished face. And I know in particular one of the problems with gloves is the astronauts' hands go after so long. So it's very extremely cold in space. So I know when they're out there after a while that their hands get cold. The other thing about it is when the suit is pressurized, the fingers get really hard to move. So astronauts will work a lot on the ground before flight doing hand exercises because with the inflated suit and the inflated glove, it takes extra strength to bring them down. So, if there's something in it that can help them relieve how hard it is to close with this, that might be helpful too. That would help with their spacewalks for like 6 hours. So they're out for a long time. So something like that.
And then so there's a couple more questions about the Amy, and we'll see which one's the extravehicular mobility unit. Another one is what materials were employed for it, and for them, particularly the hard upper torso portion of it.
I don't know the frame,
Okay. So that's one of the.
I've seen the material and some of that stuff they have, like, I don't know, I'm on this.
Okay, so you're not there, yeah. And are you aware of any upgrades that they're working on for those?
I know the suits are totally under redesigned. I know that the suits that they were for launch is different than the suits. I know they're different. They're working on those, and I haven't seen them. I don't know exactly what upgrades are. I know they are.
We did, we were talking about this a little earlier, JSU, Johnson Space Center, recently on the designs, and I believe they just sent out the 3 latest designs. I don't know if it was their main mission, but they had 3 designs that they put out and publicly devoted. So you can see the design that I don't know the direct route to get there, but I'm sure if you Google, astronaut latest designs that maybe you can find them. But there are 3 very interesting designs. They're similar. They do look a lot more flexible and slim, and I don't know if they address specifically the glove issues, but I'm sure they were. But there wasn't enough specific technical data that I can see.
Yeah, one thing I would say, the whole astronaut, the flight suits and all that stuff. We were just talking about that. It's very sexy because that's everybody's feeling for this stuff. If you really want to make money, because you really want to make a way, the ground processing, anything that comes up, that helps with that, is going to apply to the rest of it. And that would be significant. That would be significant improvement that would apply to all industries. Build hazardous stuff and build processing stuff. So that's a real opportunity for us.
And we look both ways. We look in the industry at other analogous fields to see if there are, for example, in the medical industry, they tend to have some similar technologies that we can adopt for our medical processes. So I think there are. It's one of the FinOp type focused technologies that if you come up with these sensors or devices or wearables or complex system integrations that would work well to either receive environmental information that could be context sensitive and provide it as some manufacturing process. And I think that there's a lot to be gained from it. And you're right. I mean, it is even the new astronaut suits. They have one of them was called technology for design, and it had embedded technology into the design of the suit itself. I believe they could send information to it, and it had a very it looked like very kind of like current. What I saw was limited feedback, but it would change colors. And I think that they're using it to differentiate astronauts, but also maybe if there was they were having an issue with the turn red. That's a visual indicator. Yeah, they're Russian.
Oh, great. And then so we have a question from the UK, and so they're making, and I'm not sure if I'm saying this right, an extra, a connected spacesuit for astronauts to wear inside the ISS, and so the International Space Station. Most of the time, they're usually wearing more casual, comfortable clothes, and so is there any functionality like clothing or accessories you guys might suggest for microgravity environment?
Well, I mean, I'm not an astronaut, but I can hazard a guess that I think the main functionality I think they look for is something that makes these hands free. Because they're doing a lot of experiments up there. They're doing experiments and also trying to maintain the space station at the same time. And if you ever look at videos of astronauts who work, they usually have attached to the wall a laptop, or they have little notebooks that they take notes on. So I think a big feature that would help for them is to be able to do that work hands-free and not worry about typing in instructions or looking at instructions. In fact, if you look at any astronaut training manuals or guides for doing work in space, it's checklist after checklist after checklist. And if you can eliminate those checklists completely and just make it something that, like for example, with a heads-up display type thing where the checklist appears there, I think that can make their lives much easier.
Yeah, and that's kind of the same issue. Those two same issues with ground processing people and astronauts. But, with technology, there's so much stuff that have to reference. It's wrong. You need to go look into something, you put something together, you need to get detailed. There's lots of specifications that have to be referenced. I mean, there's a ton of data that you have to reference. So if there was some way to be able to do that hands-free, that would apply to technicians and astronauts. And I've heard Andy Allen, was talking the other day, and he does the same thing he brought up, and I know working with people who fly off. And I know that's a big issue. So you just can't take all those quick. Now you watch those old shuttle launches and stuff. These guys had flip through things, which was crazy. I mean, they were emergency procedures and stuff they had in books and stuff. You can have that stuff, readily available. Voice command. I know like Microsoft record data and stuff, talking with them. I don't know. Stuff like that would be helpful.
And if it was I think, again, venturing a guess, because we're all ground-based here at Kennedy, if it's a connected spacesuit, and that information can be, context sensitive to the environment, the space station environment. So if there was an emergency, I mean, really, when you think about information at a glance, if you're in an emergency situation, you're trying to troubleshoot something, having the relevant information readily accessible in a meaningful, digestible format is much more valuable than having a stack of web manuals that you flip through to try to troubleshoot something. So if it's a true connected suit, and it can be fed status information, station information, and if there's a trigger, or if there's something that you have to do, it gives you a sort of a truncated set of operations to perform, or maybe it phones home, or it does a bunch of other things. You're already connected to the system. That would be, I'm sure, something valuable. I wish we had an astronaut here to give you a real use case.
I can tell you one thing. I know for the space shuttle, they usually have one pilot or co-pilot that will always tell them to see shuttle system. So if you could pull that, your base system monitored, usually there's somebody's monitoring. If you didn't have to sit at a computer or sit in front of the CRT working on cockpit, you could go about doing your normal job and keep track of the face system data. The same way the ground personnel, you don't have to control monitoring the systems, and the systems are powered up. Go about doing regular work, and keep an eye on the system pressures or always
No, I think that's one of the beauties in general of technologies we have today is that in the past we have to look at books, reference manuals, and find information. But context-sensitive information, it's like it takes you right to the page of the book and it knows the situation you're in and it finds the information you need. Maybe the space station, even though it's not that big, you think about it, it's the size of a football field. And so if you're working on an experiment on one side of the space station and get an alert, I mean, these systems could work as a GPS inside the space station to say, go over here, turn left, and this is where the issue is occurring on the space station.
And I have a couple also, and John, who would ask the questions, so thanks, David, who led the early part of the response. But, you know, just from hearing astronauts talk, one of the things that they sometimes get frustrated with is, you know, they have to maintain this basically a space station. It's like a 6-bedroom house. And so it takes a lot of things. And so sometimes they'd be off and going through supplies. And so if somebody from the ground just saw them and it kind of just looks like they're digging around, well, there's some tasks the astronauts working on, but then they get a call from the ground, hey, can you go do this? And it just kind of adds a lot of tasks. So maybe something to have the astronauts be able to kind of convey their point of view a little bit better to the ground, so the ground can get a better idea of what's really going on with the astronaut. And then also, and I'm not sure about the whole policies on the space station, but when for grad school, there was a SPHERES project, and we had the astronauts actually running our experiments. And so sometimes they'd be working on something, and then they'd have to go get the microphone to either convey information, or else they'd be in the middle of the task, and the ground would call them, and they'd have to go get the microphone. Something to make them be able to communicate a little bit more smoothly without having to constantly go back to a physical object. I think would be really useful. At least just some of the observations that I've seen. So, good question.
You know, the visual part of that too, because engineers and technicians and engineers and astronauts, right? They're trying to tell each other, and sometimes they communicate what they're seeing. You know, but camera was right there on what the guy was looking at and talking that would help, especially on the ground. I'm sure that they have more of that already coming in space, but on the ground, a lot of times the engineers sit up and control them, and the technicians trying to tell you what they're seeing and what the problem is. You can actually see it, you know, and with it's huge.
And apparently, so John also says awesome beard to Josh. And they have astronaut Tim Keith, who is a European Space Industry astronaut who's been giving them a perspective. And so we were just saying, great, we're really happy that you guys are there. And if Tim is willing to share with the rest of the world, you guys want to do a Google Hangout with him for him to talk about the astronaut perspective. I'm sure everyone else would really appreciate that. And then, and so apparently Tim said he would like an embedded camera and the microphone. So, great. I'm glad that was useful for that one. Okay. And so, and then we also have another question for Alessandro, from Alessandro about advantages of, and again, this is your guys' expertise, but maybe you can speak to it, of exoskeleton suits for missions on Mars or asteroids, particularly in places where gravity is not anything wrong.
I think what's interesting about this question is I had a frame of mind. You know, wearables is kind of a word that I think is emerging into our vernacular as a way to describe all these technologies that are small and light enough that they become accessories. We joke about it as being fashion accessories. We were going to hear about maybe we should have brought in as a consultant, fashion designer, but I had never thought about a wearable as a full suit. Which is a literal sense of wearing. You think about a spacesuit as a wearable in that respect. And the problems that we've seen that are larger objects that are great. So this kind of extends that metaphor all the way to a full suit. So again, not my expertise, but I think any suit that enhances your physical ability to perform your job, whether it's mining, digging, or staying grounded, or moving quickly, or providing feedback to your tasks, embedding any type of sensors, and again, providing any information that you can, if your exoskeleton can essentially be your computing system. It's informed by your movements, coupled by, we have a project down here where it's a, I believe the project called Razor. I don't know if you guys are with it, but it has sensors built into the tires or the track of the rover, and it gives it, the intent is, it reads the soil next to the regular makeup as it's traversing, so it can look for points of interest. So you have an exoskeleton, for example, that has sort of similar technology on your shoes. So if you're walking around, you're getting feedback in that's understanding. So I think it's one of those questions. It's a very good question. You can answer it in a million ways, but I appreciate the perspective because I hadn't really think about that.
I would say one thing, and like the I've always thought about the heat and the cold regulation. And if you could come up with a solution, that could also apply on the ground, it was like right now I think they use these like the blocks and the white suit. But if you could really have a really efficient suit that you could wear that would maintain temperature. I mean, just think what an advantage that would be on the ground, like out here in Florida. I mean, if you could get it cheap and efficient enough, farmers could be wearing this thing, and it would change the whole job. It'd be a hot seller if you could get it cheap and efficient. So I think thermal is one big one. I think for astronauts, one of the big things is radiation. So if you can do something to help with radiation, I mean, that is one of the constraints right now. The amount of radiation. Right now, I don't think we can go to Mars because we get that figured out. So there's something to do with detection and the parts of radiation happening. For that, I know that's the question.
Yeah, it's one of the many challenges. But and one thing I just wanted to mention, we've been talking about fashion designers. So there's kind of an interesting story back. I think it was in 2009. There was this astronaut glove challenge, and the second place team actually, the person who was on it, Ted Southern, he designed the angel wings for Victoria's Secret. So he was really a designer, and then and through doing this astronaut glove challenge, he got second place in the competition, and then he actually ended up with a NASA contract for working on fashioning gloves. So I'm not sure if he still is, but definitely fashion designers do have gloves bring to that, and just that's why we do the SpaceX challenge, is that we want people, all kinds of perspectives are gonna help us with coming up with innovative ideas, because there's something different from there. All right, and we have another question from the challenge, and it's from Andrea, and she wants to know, if I develop a technology that is able to transmit remote signals with only the movement of a finger, what would you like to control with this technology? Tools, remote systems, or something where you can, it's a wearable, I guess, that can then send commands.
That would be good. I mean, with ground processing, the way it works, we do a lot of remote operations. So we'll have the engineer be in the launch controller, and we'll have this computer, and then out in the field, in one of the processing areas, he will send command via a keyboard to open and close valves out in the field, which is executing commands to do stuff. So I guess if you had, I guess if an engineer would have to be out in the field with technician and could execute commands from where he was at, just by motion or something. I guess that would be, I can see where that would be helpful, or bringing out information, simulated keyboard or something. I guess would be with the
I think one thing we have to be careful with these type of controls is that there's something to do things with your hands. So you don't want this thing to be launch a rocket and then you're grabbing a wrench and launch 5 rockets. So, but I agree. I think anything that limits the amount of the necessary, the more natural inputs, I think could be useful for a technician anywhere, whether it's in space on Earth, working on space things, or in the factory.
So yeah, just think about a deliberate but easy movement that you can do.
Yeah, a lot of times when you issue a command, you have a two-step.
Right.
So you would have to figure that in, figure two-step. Like you said, you would want to be moving the hand, and oops, I forgot to shut off.
Right.
So thanks, and that was from Lepre Andrea. So, and apparently they do have UK, they have fashion designers there working with them. So that was good to hear. Okay, and let's see. So we're actually close to wrapping it up. So if you guys have anything, thank you everyone who's been joining us. We really appreciate it. We'll let these guys come back in, and if there's anything they want to say to wrap up. But again, we just want to say appreciation for you guys for tuning in and for sending questions. So anything you guys want to say to wrap up?
The only thing I would say is think about the grant process. So the astronaut thing is sexy. There's a lot of people working on that, but you figure out something to make a farmer's job easier or a technician's job easier. It's a lot. Make a lot of money, and it would be help the world out.
Right. No, I guess my final parting thoughts are, I love this conversation we've been having today because, like Josh mentioned, already in your questions, we can see you're thinking differently than I was thinking, at least when I came up with the question. So that's exactly the reason we want this question up there, because you guys have innovative ideas that we're not thinking about, because we may be too focused in a certain area and you're thinking differently. So I'm really excited to see what solutions you come up with to this challenge. And I've been looking at the HackPad, and I've been looking at some of the projects up there, and I can already see people are thinking differently. So, and again, astronauts not the only thing. Ground processing, help us out.
So I'm gonna tag on that. So it's sort of a selfish motive for me to be here because working in ground systems, I think with respect to wearables, it's something that we've actually been actively thinking about, and it's as we try to reduce costs, but specifically processing costs, try to make ourselves more efficient and safe. It's something that we want to invest in downstream. We think we can use this kind of technology into our routine, our operations routine, and ultimately it'll make our program more affordable. It'll allow us to do more engineering and science. So there's real fusion and real opportunity to take these ideas and these concepts that you guys come up with and really vet them through a maturation process. This could be more, at least from my perspective, within ground systems, this could be more than just a weekend thought exercise. So it is something that I want to pair these to that as well. I think we have the right influence and we have the right people. My program manager in charge of that program is here earlier. He's well aware of these kinds of challenges that we're doing. So there is real opportunity here, and again, we can apply it on the ground here. There is significant potential commercial use in many other parts of the real world. And so I just want to thank everybody for their time, especially those folks from all over the world that are heavily engaged in this. We've seen a lot of great ideas already, and this has been a great discussion. So really appreciate it.
Next one, I have one more thing. You mentioned affordability. I think what we also have to remember is that even though the astronauts are the ones out there touching space, the ones who get the astronauts up there are here at the Space Center. And so if we can bring our costs down, that means we can do more of those cool missions to other places. So if you want to help the astronauts, you help the ground. So we have to help the ground first.
Yeah, and if you can make it better and more efficient, then we can do it faster.
Yeah.
And we can do it more often. So thanks. And you guys, there are a couple more questions that have come up, but if you guys want to post those on the HackPad, as David said, he's going to be monitoring that so we can get them there. But thank you guys so much. We really look forward to seeing you guys' solutions. So again, we're going to reiterate, please put up those 30-second videos. We want you guys to explain what your challenge is and put all your resources on your pages so that we can get some great ideas and we can build off of them for everyone. So thank you guys so much.
Thank you.
Yeah. We say that. Okay, okay. No, what? And you will be free like you did. You know that you could like
So, right. So if okay, so assumption is that that's why this is the side function. If equals to 0, okay. So we always items on right, and that's why we always say what is why do you say if you only say okay, so you say two functions. We still have to say multiply a if like again, yes. Yes. What were you doing last yesterday? You know, you are doing that. Now we have okay, so like now, okay, so you use the sorry. Now like you follow the asteroid as a space as a space cover. Yeah. Now you need to add another thing. What how he tried out? Yeah, he tried out. He tried out with yeah, no, but we have to show it, right? Actually, no, you know what? I think we do what's the better in a time such an L5. And actually, you like such an L5 and use that as a rocket that we are going to use rendezvous. L5 is okay, such an L5 use a simplified model of it on cell basis. That do the like you don't have to do Gaussian stuff. Just do a simple Hopper transfer the asteroid. Yeah, and okay, do it to the asteroid first. Then we can talk how we can get the asteroid. I'll say so. People like that is not oh, I think it's very full. So you can see we have arrows and here, that's what we're trying. Good. One. Yes. No. Okay. Yeah. Yes. Yeah. No, not really. So how to make it feasible to do that? Okay, all right. Okay, okay, anyway, all right, anyway, first of all, the biggest point we have is that, technical. So, yes, I understand that process. I really get it. So it is. So okay, so once we get to the point but like you said about
During that time. But my name is Callie Burke. I'm here from Kennedy Space Center, and I'm the lead for the Space Apps Challenge team here at Kennedy. And so of the 45 challenges that are going to come up this weekend for the Space Apps Challenge, April 12th to 13th, we have 3 of them. And so we're going to have experts from each of them who will be talking about those different challenges. So they're going to introduce themselves and the challenges, and then we'll be going to questions. So we'll go first to do the space wearables.
Hi everyone, I'm Peter Miranda. I'm the challenger for the Space Wearables Challenge. I'm here with and Brenda. So what our challenge is about is developing space wearables for both mission space for astronauts and also for training space for ground operations to missions. So I look forward to seeing what you guys come up with and the different kind of good future things this time.
Okay, and next we'll go to, also, we're going to have, we have an additional party who's joining us for space wearables. Andy?
Hi there. So I'm Andy Allen, and former astronaut who research shuttle flights. We have an and currently working on a contract here.
Thank you for joining us. We'll go to Ray Wheeler.
Hi, my name is Ray Wheeler. I'm a plant physiologist, and I work at Kennedy Space Center in Aurora. And the challenge this year is somewhat related to the challenge we had last year for Kennedy Space Center, entitled Grow Food for the Martian Table. For any of those that might have participated last year, we had a challenge related to deployable greenhouse systems for space. And so this year's challenge will be to extend that, the ideas that, great ideas that came from last year, but think more about how we might connect food production systems with habitats. What are some of the issues that we can consider doing that? And like the other teams, very anxious for the great ideas that come out of this whole effort. So happy to be participating in this.
Thanks for continuing to support us. All right, so Phil and Jim, if you guys want to introduce yourselves and the challenge.
Hi, I'm Dr. Phil Metzger, and this is we work in the granular mechanics and regolith operations lab here at the Kennedy Space Center, and we're supporting a challenge this year for prospecting asteroid prospecting. And the idea is to have a game that will hop from asteroid to asteroid around the solar system, prospecting for resources in order to continue the journey as you go. And the reason that we're interested in this, motivation for this challenge, is because the asteroids in our solar system are, on one hand, a great threat to predators, on the other hand, a great opportunity for predators. And so we think by mining the asteroids, we can at the same time set up planetary effects and get a win-win situation, bringing in billions of times greater potential resources for humanity, as well as making it safe for the solar system. So the idea of the game is to get more people interested in asteroid mining and to look at strategies for hopping through the solar system through different asteroids.
All right, thank you guys very much for joining us. So, and another reminder is that these are all challenges. So anyone who attends one of these 3 challenges over the weekend and does a project, and even if you're not nominated for global judging, as long as you complete a 30-second video and you do that with your summary and all your resources on your project page, you'll be eligible for a launch viewing opportunity prize. And so each challenge will have a winner, and so they'll have 2 team members who will be able to get be invited to come to Kennedy Space Center for a launch, and they'll each have 1 guest. And so last year we actually competed for the main launch, and they were global winners. Both the winners of the Kennedy Space Center and the State House global winners. So we're looking forward to having that again and seeing all you guys' great projects. So, all right, we'll go ahead and get started. And our first question will be for Andy. So, So this relates to the space wearables challenge. So when you were in space, were there any activities that you did where it was really awkward? Like you wish you had something to write things down on or record notes, or what was hard about being in space and doing research?
So let me try to simplify, since everything is a little awkward. Probably the most awkward stuff to do up there is really some of the personal hygiene stuff. As zero gravity, it's hard to push it. Okay. You can't just spit out your swallow. Shaving, washing your hair. Hard to move around, hard to keep everything under control. Simply things and writing things down. This is not from a get the job done.
Okay, sorry.
Getting out of the spacesuits and things like that.
So I don't know if everything, but you're
a lot of the data, a lot of people we got to look at a variety of different places. Very intrusive time, public social care, watching EVAs, having a simpler place to look that happens. Had a lot of astronauts were on the radiation quarterbacks.
Well, that's all it's important. Yeah. Yeah.
Other people will have to move around.
Yeah, you use that. The only one chance. Yeah, like anti-air.
Alright, thank you for answering that. And next we will, and I just want to remind everyone that we are using the question Q&A function of Google Hangout. And so if any of you guys have questions, you can submit questions that way and we can answer them there. So next we'll go to the space wearables team here.
The thing is, how the to slow down attention.
The question I have for you guys, and this one actually, this question comes from an email, and it asks if the project, so there are wearable tech that's mentioned on HackPath, and they want to know if the project will be considered lesser if it doesn't use one of those wearable techs mentioned on HackPath. You guys want to go ahead?
Like in this time frame, are you having the analyst?
Yeah, you don't have to use those lists listed as just examples. It's more especially we put some things up there, but don't get into it like that.
So we can say, we got to say,
what is the ground house?
we can say,
Just want to kind of use that out.
Just give a little bit of background on that I've been out since about 29. I started out straight out of college with technician. So I worked on the startup I worked on it. It's maybe my background. This practice. Right now, I'm working with Brian.
Okay, what is like
that part of
I'm just saying, these are reasons for the exist. Yeah, and then how the
we have a lot of different types of values. So there's a variety of that. some of the things that you can kind of keep in mind about the process and the technicians go through, they're really similar to what Andrew was saying about last time. So,
That's obviously saying it. We save the amount of values and
a lot of the way the engineering is so they have videos with information.
That's the show.
Similar to what Andrew said, communication with that is really good, sort of good to follow the sequence.
So our next question is back to Andy, and this one comes from Twitter. R. Schneider SO, and it asks, while residing in the space station, the International Space Station, what are critical things you need to know? And I just talked about from an astronaut point of view. But what are the critical things at any given time that you need to know? I apologize. Can you start over? You're muted.
So first and foremost, is the astronauts need to understand any and all emergency procedures immediate action. The most important thing for them is to be able to, in some cases, go to the station. In other cases, that you go to a checklist that on a short time and you go out. Just whatever the steps are that the pressure station relays. Need action steps right away.
What would you say?
After that, it's mostly the science experiments. Mostly science experiments. And generally, we are optimistic to discover time at the space station. And nothing, sure, we can all this exactly like this. And so then we got to deal with a lot of hardware complications, which is pretty cool. But something that the astronauts have to be able to actually try to save it.
Okay, great. And then we have another question from the questions on Google, and it says, "Are clothes, suits that are worn in space, are they reused or recycled?"
Yes, is the answer. The astronauts really don't use any of the clothes that they wear. So you are allowed to keep some of the Land's End type shirts. Very awesome. Give them back to NASA. Including underwear. So NASA likes all that.
Great, thank you very much. And if and thank you for joining us. Another space variables question. We'll do one more and then we'll switch over to the greenhouse. So, I think we talked about some of the questions. So, this one's for David and Brad. So what are some of the ways that you guys are, some of the interests that Kennedy has in developing more and doing things for our center?
Well, I think some of the things we're doing right now, with
Slow down, accelerate.
are things that where we bother QR code. They're in the process of testing out. They actually use the dog to check it out. They're not in the application. I think that you can work to other different applications process. Some of the sensors on the ball so that it actually makes the ability to sense the different problems. So those are two small examples. I'm not sure if that's it. Where it's probably technology they apply these everywhere. There's a lot of work that's hands on with the processing of it. So whatever sounds free, it's a good benefit.
Thank you guys very much.
Yeah.
Switch over to working, talking to Ray Wheeler on the greenhouse now. So the first question for you is how some of the different locations, whether you're at Mars or Moon, might affect your greenhouse design.
Okay. The setting will have very significant effects on concepts and designs that you might choose for greenhouses or plant growth systems. If lighting is a big issue in terms of growing the plants, it's what really drives their growth and production of oxygen and food. And so if you go to the moon, for example, if you have a low latitude on the moon, that means you have 14 days of light, 14 days of dark. So that's something that you have to consider. That means you probably have to have ancillary lighting, like electric light systems, perhaps, for the dark periods. Or alternatively, if you went to a very high latitude, south pole, and you got on a ridge line, you might have much more sunlight, maybe up to 24 days. You could capture sunlight if you were low in the horizon. So it would depend on the setting here. If you're going to Mars, you would have sunlight available in the transit mission all the time. And so that would be a consideration, perhaps, in, say, greenhouse or food production systems while you're traveling. And then when you get to the Mars surface, you have to think about now your harder things done. You only get about 23% of light, which is the Earth. So using direct lighting could still be used, but you have to account for less light getting to you. So electric lighting systems maybe become option there. Supplementing. Another interesting thing to consider with Mars is that it gets great dust storms. So if you have lighting systems that tend to direct sunlight, you have to consider with dust storms. Lots of interesting things to consider.
All right, great. And then we have another question that comes from Zach Trolley, and it came through Twitter, and it asks, are there partnerships set up to use greenhouse technology to solve hunger on Earth? And I guess how those tie in with the work that you guys are doing here. Are there tie-ins?
There aren't formal partnerships right now. I can say, for example, that we work with groups that are affiliated or directly involved with the U.S. Department of Agriculture, just as collaborative projects. But I think there's a very interesting underlying theme of food production for space and for Mars and what we face in terms of food production challenges on Earth. If you think about sustainable living approaches on Earth, or in space, you have to think about the same sorts of issues and challenges. How do you get the most out of the resources that you have? Can you recycle? Can you improve the efficiencies? Things that are very relevant for space missions, like going to Mars, I think are also very relevant for sustainable living on Earth. So I think there's some interesting parallels there that both space and the terrestrial agricultural communities can benefit
Great, thanks for answering that. Okay, the next question we have for you is, how might the habitat that the greenhouse is going to be servicing, how might the size of that style, what those factors are, how would that affect greenhouse design?
Yeah, well, there's lots of scenarios that various challenge teams might come up with. I'll just mention some that come to mind for me. They could begin with systems that perhaps aren't targeted to the human habitat. Say you have a directly connected and at the same pressure, and maybe you just partition it in terms of a hatch or something like that. That would be one scenario that would impose certain challenges. Perhaps in that case, you might have a lot of humidity in that module that might be a consideration for the rest of the habitat. Or you have to exchange the air between the humidity. Another situation is maybe you have them more partitioned. It could even be a separate thing. Maybe the plant system is positioned in the greenhouse is positioned in an optimal setting, somewhat close to the habitat, but never for light interception. So then you have to consider how do you access that. If you don't have connections through robotic systems. Would you have to do EDA, so-called spacewalks, where the crew has to go to the greenhouse to create things? Or maybe here's a third application. Maybe they are smaller modules or pods that would be attached to the human habitat and then that would be moved out along the track, opened up, and then when the plants are done and mature and ready for harvest, you can bring them back to perhaps an area service the growth systems, picking up the food, and that's unloading the oxygen. Because I think there's a lot of situations that could be considered, and I'm looking forward to various ideas.
Great. And then what are some of the vegetation projects that you've worked on, or that just Community Space Center as a whole has worked on that either have flown space or at least flying space too?
Well, a lot of the work that we've done, Kennedy Space Center, has been largely what we would say is ground-based research, looking at controlled environment systems, using conventional approaches of electric lighting, trying to stay up to date, also using hydroponic systems where you can serve and recycle the water and mineral nutrients. But we've also been engaged with some spaceflight experiments, as has a much broader external community, very often with NASA grant funding. And so those experiments typically pass 2 or 3 decades have flown in the space shuttle, and in the past decade have gone on to the International Space Station But as you might imagine, in that case, in those settings, the plant chambers have to be small. So you're not throwing anything very large. You can't have large power budgets because they put up high strains. But small plants, wheat seedlings, Arabidopsis plants, which are very good research, radishes, Zuna, peas. A lot of these have been grown in the Russian module, the International Space Station. So they're interesting challenges. In space, you also have to consider water. Because you have no gravity, things float through them, so how do you contain the water? So separate challenges in maintenance.
Okay, great. And then what was some of the things you found interesting?
Yeah, no, I'm not saying
for the 2013 Pleasant Greenhouse Challenge.
No,
The elements of projects that were interesting to see and variety to put it out.
Yeah, no, we didn't. I didn't.
Well, there were some great projects last year. They came up, they addressed all sorts of approaches and also continuing
I'm saying use the
greenhouse or food production systems.
Use the rocket.
Some were small, others were robotic managed systems, others were larger human-dependent approaches.
Do you guys know how to change
Policies and issues related to power budgets, electric lighting, what types of crops that they were recommending, and then they would justify their choices based on the research and literature that they reviewed. Wanted to use the most efficient technologies like LEDs, solar collection systems, concentrators, and in the cultivation techniques, different suggestions on how to do that. Use of hydroponic systems, aeroponic systems, very, very thorough. I was really impressed. The range of the ideas with such a short time.
And then one last question. There's an interesting conference coming up in Europe next month, correct?
There is indeed. It's called Agrospace 2014. Every 2 years for about the past 8 or 10 years, an Italian company called Water and Water Support Group has sponsored this meeting in space Africa. And they hold the meeting in a small village called Sperona, Italy, between Rome and Naples. Very beautiful setting. And they talk about issues and challenges related to space agriculture, and then also how they pertain to terrestrial agriculture systems and sustainable living. And so there will be this conference coming up in May, and I know that some of the participants of last year's Space Apps Challenge 2013 will be attending this conference. Some of the student groups from Rome, since we're not very far away from the meeting, will be presenting posters. But I think if any of you in Europe are interested in this, there's still time to check out that meeting. You can go to the website, just type in Agrospace 2014 and it should come up.
All right, thank you very much, Ray. And we have one question, another question for Andy Allen before we switch over to Asteroid Prospector. And so, Andy, what did you enjoy most about being in space, and what displays might and other wearable technology that's being developed might enhance that enjoyment?
Okay, well, that's a good question. So, actually, the best, most enjoyable feeling is gone for a ride, get back, and see family, Tells you that you're going to do what you can. While you're up in space, of course, it's a fantastic opportunity to learn a lot. Probably for me personally, it's a great astronaut. You is probably the most important. And after about the second halfway through my second flight, I actually kind of turned towards looking out towards the stars down there. We passed through for quite a while, and the view that you see from down at the stars is really well away. The clusters that you get fascinating. You see maybe 200, maybe 300 billion stars. A billion planets just in our galaxy. And maybe a few hundred billion galaxies. The other enjoyable part about it all is going to be the moving around. The hard part is stopping. Stop. Our body stopping. As far as wearables, again, it's probably the situational awareness that everybody else want to do. Well, I'm going to a smaller area. Space station. Got to get to a point. It's got to be the things that require immediate action. Got to be able to get to it. So we had these all kinds of pieces of data and have more action.
And then a bunch of wiki websites.
Thank you. And then as a follow-up, when you talked about enjoying looking at the Earth and the stars, would you ever then go figure out exactly what you're looking over or what you're looking at? Or do you just enjoy them in the moment?
Well, I enjoy it in the moment, but at the same time, you try to figure something out. For example, the first trip I made was trying to find the constellations that I knew I didn't know where you get up in space. You can't find the same constellation. You're just motivated by a lot of other stars. So it's a little interesting on how to find. But the moonrise, sunrise, like sunset, pictures will never do it justice. For astronauts, if you look at a sunrise or sunset, we'll try to count names all over. Most of the astronauts believe they can see probably. Do that on a pure ocean day.
Great, and thanks again for joining us. We appreciate your time. Okay, and we'll switch over to Jim and Phil. And first of all, do you guys want to talk about where you guys are at right now?
Okay, we're in the what we call affectionately the fishbowl. This is one of the side rooms of the Swamp Works, where we are overlooking the high bay of the space station building. This is where the different elements of the space station building were assembled and then put together and tested prior to launch. Right now, it's not being used for assembling space station, obviously, because the station is all up in orbit. But we use this room for meetings, and it's a great location that reminds us what we're doing, hardware, putting people in space. It's a great place to meet.
Great. So what are some of the interesting projects that SwampWorks has going on right now?
Well, we're working on a variety of projects that are they cluster around the themes using resources in space and how to use regolith in space. So we have one project working on the development of 3D printing with regolith. And by the way, let me mention regolith is a term we use for broken up rocky material on the surface of a body in space. So it would include sand, dust, gravel, boulders. And we want to use regolith as a building material, so we can do 3D printing with regolith to make buildings directly. We also look at how to do excavation of regolith so that we can do chemical processors where oxygen can be extracted from the regolith. We also look at mining the ice. And one area that I personally work on is studying how rock exospores soil. Jim has been doing a lot of work in that area with Morpheus. Do you want to talk about some Morpheus work maybe?
Yes, so Johnson Space Center has developed a lander test bed that for vertical takeoff and landing and service. They've been doing their testing here at the short landing facility. It's kind of neat. He set up a hazard field for test landing. It's 100 meters by 100 meters. It consists of craters and boulders and flat areas where Morpheus can land. So they take off from a concrete launch pad at various distances from the hazard field and ascend to several hundred meters and then land in this hazard. They have some very interesting videos on YouTube. So I'm going to search for Morpheus lander on YouTube. You'll find some very interesting videos. So we're looking at, like Phil was saying, effects of landers on launch and landing. So our hazard field kind of looks like the moon, craters and boulders. And when they land, they pick up a lot of dust. That's what the study is.
I've also been supporting a couple of asteroid missions. I'm supporting the Osiris Rex mission that will be sampling an asteroid, bringing the sample back to Earth, doing analysis on that. And several of us in the GMR lab have been supporting the asteroid return mission, looking at how to grab an asteroid and bring it back to Earth. And we're helping the agency discuss what do we do with the asteroid after we bring it back. Which gets to this topic, prospecting asteroids and using asteroids as resources.
Great. We have a couple of questions from the blog. So the first one I'm going to answer is from Kyle, and it asks, will the games be judged based on completeness on April 12th or on the 17th? And the answer is on the 17th. So we won't be looking at the project pages for any judging prior to April 17th. So that was the first question, and then the next one is another one from Kyle that comes off of Phil's blog, and it says, do you have any articles besides the one that you have on the blog that you suggest to get material about asteroids?
Background material for asteroids. Jim, do you have a list there? You want to?
Yeah. For asteroids, you can do a search for include asteroids, regolith, space mining, and that should pull up a lot of resources, NASA resources as well. Any particular?
Well, if you want to find a book from the library, a classic book on the topic is "Mining the Sky" by John Lewis. That's a really classic book, and I recommend it for anybody who's interested in space resources. There was another book that John Lewis wrote with his wife, and that one I believe is called Space Resources. Also you can look into the website here. That is Prospecting the Asteroids.
Private space flight, so
So you can Google for that. And
as far as getting to asteroids, I think Dick Dell has a website as far as related to asteroids, how to reach them. Just one of the interesting things is that communications, if you're interested in communicating with asteroid prospect from Earth, it's going to be considerable delay. Probably at least half an hour.
one thing I think we should point out, one of the most important points, is that the asteroids are very different from each other. They're different classes of asteroids. And so to have some realism in this, you need to account for that fact. The reason for it is because asteroids are the leftover building block material from our solar system. And while the solar system was forming, there was segregation of different types of materials. The solar wind is blowing outward, and heavier elements would not blow out as much. They could coalesce into bodies closer to the sun. But the lighter materials blew outward before they sort of polar region before they coalesce. So that's the first reason that we have different kinds of bodies in the solar system. The outer part of the asteroid belt might have more carbonaceous materials, and the inner part of the solar system might have more stony materials, perhaps. And I should also mention that the asteroids in the inner solar system don't last very long on geologic timescales. They eventually crash and hit anyway. But it's being continuously replenished by bodies from the main asteroid belt. So as Jupiter disturbs the trajectories of those bodies, some of them get flung into the inner solar system. So the near-Earth asteroids are coming primarily from the main asteroid belt. But as I mentioned, there's some difference in materials based on this distance from the sun. The second and perhaps more important reason for different compositions of asteroids is that these asteroids have coalesced into bodies in the past. And these bodies then sometimes collided and broke apart again. Whenever a body coalesced to greater than a particular size, then it got hot enough that it would melt, differentiate. And so the heavier elements would sink to the center and form the metallic core of the asteroid or the protoplanet. And the lighter materials, the silicate materials, would float to the top, and you could have heavier materials in between. These differentiated bodies then collided and broke apart, and so now you have asteroids that are pure metal that came from the core of the protoplanet, and other asteroids would be mantle material, and other asteroids would be crustal material. And so, for this reason, there are many different classes of asteroids, and different ones are being flung into the inner solar system. So prospecting asteroids involves thinking about what kind of asteroid you want to go to, and what types of materials you're going to find when you get there.
What are the most valuable materials?
Yeah.
Whether, I mean, water's a valuable commodity that's lacking. You need that for space travel. But the reason to go to asteroids, if you want to do mining, is to bring back valuable materials that
Yeah, so if you want to use the asteroids to enable activities in space, water is probably the most valuable material first, because you can use it as a radiation shield. You can use solar energy to electrolyze the water to create hydrogen and oxygen, and then use that as propellants. if you want, the hydrogen could be combined with carbon got from the carbonaceous asteroid, so you can make methane, and that's easier to store in space than hydrogen is. It's a denser fluid, and it requires less fuel and active fluid to keep it liquid going off. So you might make methane as well as oxygen balance. But it all starts with the water. In addition to the use of water, Jim mentioned bringing materials back to Earth, and so there's a lot of interest in mining the platinum group metals. Those can be found at an M-class asteroid, a metal asteroid, but ironically, the highest concentration of platinum might be in the LL chondrite asteroids. LL stands for low metallicity, low iron. But despite the low metallicity, they actually have very high concentration of platinum. So an LL chondrite would be a stony type asteroid. And if you mined a stony asteroid, you could get the platinum, you could get water, there might be 20% water from hydrogen minerals in that type of asteroid. And you could also get the stony material that you could then shield to use as a re-entry method for bringing metal back to Earth. So you could use all the different materials. You can get a lot of information about the different types of asteroids just by looking on Wikipedia. But that would be a good source for that.
One other thing to consider, asking to consider is how much energy does it take to process that? So that's something that you need to consider.
All right, thank you guys. We have another question from Jacob, and it asks, how much realism do you expect to see in the game? Does it have to be close to simulation, or could it be more abstract, just getting across key points and information?
Well, I think that'll be one of the things the judging takes into account. You've got to be realistic about what you can do in the amount of time. And we understand that. But remember, it's a competition, so there are other teams that are going to be trying to put in more realism. So it's going to be a judgment call on what you want to try to accomplish. To try to bite off something that's realistic, something that you can complete, because a game that's finished that can be played is better than a very realistic set of ideas on a PowerPoint chart. So keep it achievable, and if you have more time, you can add more realism. But we understand you're not going to replicate the entire reality of space mining in a short amount of time.
Okay. And we had another kind of a fun one from Alan Shaw 164 on Twitter, and it says, "I fear asteroid strikes for our descendants. What can you do?"
Do you want to take that one on?
You repeat that?
What can we do to stop asteroid strikes?
Or, yeah, protect us from asteroid strikes.
Well, there's ways of deflecting asteroids, and probably the most efficient ways to do it before it gets too close to the Earth. So people have looked at ways of deflecting asteroids by causing material to break apart asteroids when they're far enough away, so that they're in some way you can deflect their original trajectory. So you have to know that it's actually coming towards the Earth. Worst thing that could happen is you deflect an asteroid that wasn't coming towards the Earth and make it come towards the Earth. That would be bad.
So some of the ways to deflect an asteroid could be using the asteroid material itself. Like Jim mentioned, use the water on the asteroid to create propellant to push the asteroid. Or you can fling rocks off the asteroid if you have enough time and fling the rocks fast enough. Another idea is to crash a rocket into an asteroid, that's called kinetic impact. Another method is called gravity tug. If you have plenty of time and the asteroid's not too big, you simply park a spaceship next to the asteroid. Now the asteroid gravity is pulling on the spaceship, so you have to keep burning fuel to keep your distance. And the gravity between the spaceship and the asteroid actually pulls the asteroid along as the spaceship spends its fuel, but maintains the position of the asteroid. It tugs the asteroid. That's called gravity tug. And another method would be in extreme circumstances, you light off a nuclear bomb. So the shock wave blasts the asteroid. But I think the most important thing we can do for our future descendants is to get industry started in space. If we start using the resources of asteroids, this will give humanity literally billions of times greater resources in space. Billions of times access to solar energy, to metals, and to all the other resources. And if we have robotics, building robotics, using space resources, space energy, we can create the capability, the industrial capability that is thousands of times greater than we have on Earth, billions of times, or even billions of times. And so if we start down this road and we start industry, we start civilization in space using robotics, then for the first time ever, we really have the ability to take ownership of our solar system. We really will get the ability to take control over all the asteroids, to map them all, to figure out what we want to do with every one of them, and to really keep the Earth safe. So then we can move on to the next problem, which are the most tested comets, which come at us with a lot less warning and a lot harder to detect. But one big at a time. So I think take ownership of the solar system by getting industry in the solar system first.
Okay. Well, thanks. So we are coming close to the end. So do you guys have anything else you wanted to comment about Asteroid Prospector before we wrap up?
Well, it can be a fun project. I think that if you make a game that people really will like to play, then you can commercialize it, sell the game, who knows. Make it an actual app that you can distribute on the iPhone or other phone platforms. Or you could, last year we did Moonville, the Moonville game, and we thought everybody would do computer games, but one team actually did it as a board game with physical parts. And if you made it a board game where you could 3D print the game using a commercially available 3D printer, that would be another cool way to distribute the game electronically that people can actually play. So if you make it a fun game, make it where people really want to play it, who knows, it might go viral. Maybe everybody on the college campuses will be playing Asteroid Prospector. But I think it'd be a great way to get some publicity for space mining, for defending planet Earth, and for the space program. So I think you should have fun and see what you come up with.
All right. Well, thank you guys so much for supporting Space Apps and joining us today. We appreciate it. Okay, and we have a couple of questions that have come in about space wearables from Alessandro. And so these concern spacesuits, and we actually have, we don't have our astronaut on now, so Steve will have to go to send on an answer later about the spacesuits. But one of these questions is, what's the state of the art for spacesuit water vapor management? And Nick, could you talk about at least how we do that here on Earth?
And this file is actually yeah, Megan.
Yeah, I think that was good. Do you guys have anything else?
Yeah, so it's like space coin. Yeah, space coin. The coin, the little turkey coin that has S connector, so S, letter S, very, yeah. It's like just a normal yeah. That's true.
Sure, yeah, this is this conference here at KSC. And this is the lab we have here, a lot of great work we're doing for surface systems. There you can see a lunar regular kit where we're simulating the lunar environment and testing out our robots here. Good tour. By the way, this is where this hangout would be held. There's a lot of cool research people here, state of the art.
Thanks. So we'll go back to Ray. Is there anything else that you would like to add about flood greenhouses before we wrap up?
Well, I heard a question earlier on how real or realistic some of the challenge concepts have to be. I would suggest if you're interested in the Grow Food for Martian Table Deployable Greenhouse Challenge, don't feel constrained that it has to be super realistic and it has to absolutely work in space. If you have ideas that are maybe a little bit more farther out, I wouldn't hesitate to propose those and build challenges based on those ideas. A lot of things can happen in the next few decades in terms of technological improvements, plant genetic engineering, so don't feel constrained. If you want to add details and reality, that's great too. So, but just thank you for participating.
All right, and thanks for joining us, Ray. So thank you really to all our subject matter experts. We really appreciate you guys taking your time. And we look forward to working with everyone over this weekend. So be sure to put your questions in the hack pad so that everyone can see when answers come in. And we'll be having more detailed Google Hangouts that'll focus on one challenge at a time. It'll start at 1:15 on Eastern Daylight Time, which is GMT minus 4 hours on Saturday, April 12th. So we look forward to seeing everyone then. Thank you, guys.
Hello. Hey. There you go. No, that's all. Well, they don't have to do. No, I'm going to get them to submit by 1:30. But they don't have to have their videos up by today. I think they can. I think they can edit the project still once it's. I think so, because even all the international, because you should just be able to create the project in that first section, and then you should be able to go through and add additional content to it. Yeah, like I think it should be right, because you can go up and see other projects that only have bits and pieces. Like they've already created the name, but they don't have all the resources and all the documentation up there yet. So I'm pretty sure they should be able to edit that information. Yeah. No, not a problem. That's all right. Okay. Bye bye. Okay, everybody, listen to me. I'm over here. Okay, let's go through. We'll just run through some of the stuff you need to have ready for 1:30 for the teams, the challenges, the pages, judging, and all the rest of it. So I'll be pretty quick because I know you guys are still working on your stuff. So don't worry about this. Oh, okay, yep, 1:30 deadline. So we'll try and do it then. Lunch is coming at 1 o'clock, so try and get your stuff done before 1 so you can eat. Otherwise, you will eat between 1:30 and 2:30 when the presentations start. So presentations, I'll go through that in a sec. We'll have some judging and then some awards. Everyone will get an award because we don't have that many teams, so that's fine. And then after, if you want to hang out for a little bit after, we can pop down to Pancake Manor, just around the corner, if you're interested. Otherwise, you can go home and study for whatever you got to do. So make sure all the team members in your team are registered for Brisbane. So I'll show you what I mean by that. Ensure your team's got a project and you've created a, so that's your team name and the project name, whatever you've created. And make sure your team members are assigned into that project. I'll show you how to do that. And make sure you fill in other items there, like choose a license. So if we go to your pages, so your page will look a little bit different because this is cropped out some of the top menu. But once you're logged in, you should see something. Yeah, I'm just trying to show that the front screen, you should see at the top of the page, when you log in, at the top of the page on the right, you should see the event where you're registered for, and it should say Brisbane. If it doesn't say Brisbane, it will say register. So click on register, this is for each individual, and then click on Brisbane to register for the Brisbane site. So that's the only way we can add you to the global judging, and this thing doesn't want to work. All right. So up the top there, it's got login and register. So once you log in, it'll change to registered for. So we'll have the event up there. So we're looking at, don't remember the screen. Let me put that up there. So we have registered for in Brisbane, and then what you want to do is under projects, when you go create a project, have you guys created a project yet?
About to.
Yeah, that's all right. That's all right. That's all right. So you put your team title in there. You put the challenge which you're applying your project for into there. So for a license, you have to choose one of the licenses, and there's a few to choose from. But if you go to choose a license.com, GitHub have provided a quick overview of licenses that you can choose. So if you want to use that as a resource just to work out what license you think you want to come under, and it works out down the bottom here whether it's not code, if it's videos, and information there. So you might want to use this one, more choices.
Is the license applied to the entire project or?
Yeah, so it could be parts of the project. So if you've got images and video that are separate.
Can we exclude images?
Yeah. So this is for some of the code. It'll have a look through. It'll give you a description of what's covered, what's not covered, and how you can subsequently use the code, or how you allow others to use the code after that. So check out that site, choosealicense.com. That was it on that side, I think. So presentation, well, we don't want to go too long and don't want to go in too much depth. But there's only, at the moment, the two teams here. The other team, I'm not sure where they are. But, so it's just you guys that will be presenting. You can do it in any format that you like. PowerPoint, Prezi, whiteboard, I don't know, iCloud, whatever you want to, anything. But one of the main things you want to work out is, what was the challenge? Because we've got two judges that will be here. So just explain to them, because they probably don't know what the challenges are. So what challenge you chose, what was the concept for the challenge, and what solution you developed to try and tackle that problem. So we'll go 15 minutes, you know, it's not a problem. There's only the two of you, the two teams here, so you're not going to have a big, we're not tight for time. And so the way the judging works, well, if it's only the two of you guys that are presenting, submitting, two of you are going to get prizes somewhere. But we'll be put into one of these categories, and one team will be for one of these, and the other team will be for the other one, not excluding the other area. So we can't have the two teams, you know, best use of hardware. Well, you guys don't use any hardware, but best use of data or most inspiring. They have to be in two different categories. So we'll work that out, because there's only two teams. We'll work out which ones we go into. And the people's choice, well, we'll work out who they are. So with the prizes, we've got 3 prizes. The first prize, so people's choice, we've got is a silver plan on GitHub. So we've got should have been 20 repositories, private repositories in there as well. And then we've got 2 other prizes, but we can probably work out how to get those to you guys. So
What about we get like
I don't know how that's going to happen, but we can ask. We can give them a GitHub voucher, and they can give us some food.
There's $600 worth of GitHub voucher. We only asked for like $100 of pancakes, so.
So we've got those, and we'll give those to you guys. So that's it. So make sure everyone in the team's registered online, registered for Brisbane. Make sure when you do the project pages that you can add all your team members into the project. And those project pages will be editable up until Thursday the 17th. So for us, it's a little bit later because it's Thursday the 17th in probably the US, not for us. So we'll have probably the morning of the 18th. And so, given there's just the two teams here and both of you guys will be nominated for something, you'll have to develop a 30-second video to go along with your project. All right, so something to think about, but they don't have to be completed until Thursday. All right, so you still got more time to do the video and all the rest of it and add more content if you like. So I'll come over there, and if you have any questions, just come and chat and we'll work it out.
The other guy. Yeah, no, the other guy. Yeah, that guy. I don't know who's saying.
Well, like, I think it's back. Okay, well, we've got the attendance list.
Yeah.
What they say. Hey, can we have the attendance list or yes?
Yeah.
From yesterday, please?
Dionysius or whatever his name is.
Yeah. I'll come over there. I'll log in because I should be able to see everyone who's registered, and I'll work out who you're looking for. Leave it there.
Okay. Well, the video we can just get a talk over with these slides on, pretty much.
I'll do it. If we do it the next hour.
Yeah. And then we could probably do record an animation of that GMAT thing. That's for like 15 seconds.
Unless you want to become.
Have you fixed that thing up yet?
It's not this. Like, wait, it's not that much.
Talk about that part. We don't need that.
No. What we do. Actually, no, we have to calculate the how much that would be extra. That's fine. You can check it out. Pretty sure it's solution. Pretty sure it's that way. What's here? Is here.
Yeah, you put it in the Excel, you put it Yeah, I'm just gonna upload it in now, submit it, so that, and wait. That, well, you didn't get a Dropbox. That's not in the so I made a Dropbox that showed Dropbox.
took about 2-3 photos of that. You guys have Dropbox?
I do.
I have Dropbox. You can just upload files. Yeah, it's just what's your email for Dropbox?
Yeah. It's LEO. It's my. Yeah, so either way, I don't want to call. Oh yeah, great, because
I'm sharing this with you. That should be the oh no, the that class.
actually, I can't do that. Yeah, it's like it doesn't.
This is upload back to this file.
Oh yeah, are we collecting the gas in space maybe? Just collect the shooting stuff. Okay. Yeah. I'm not quite sure what this is for, but I think it's how much coding has been something well,
It's not my idea to use that. I know that we use this. Not me. But
yes. Yeah. Then I told Andy to write that. Yeah. I remember now. Yeah. So everything is did.
Why would you do that? I agree with me.
everything you did yesterday was,
stuff was good.
Yeah, it came faster.
Let's keep on changing.
So the important answer is that we can't. So I think we got enough. No,
We actually explained what information. You guys actually make it or awesome. You're right. You're all right.
Okay, how do I fit 10 minutes in that one? 30 seconds. What?
I have a camera.
Yeah.
That's good.
Yeah, no, at first someone had said abstract. What did I Oh, well, it has to be. It has to be. Someone has to project the simulation of. Oh, I'm just going to that. Fiddle around with the. Yeah.
Just move the button and then just move it on. Purple? Yep.
Yeah, you can be able to talk to him. Basically.
Yeah, sure, okay, but what are we talking about?
About everything. 30 seconds video of everything.
Do we win or what?
Yeah.
What?
Because two groups, two teams from Brisbane, so we bounced with one. Woo! We win!
Oh, by the way.
Dude, we're my default, best winning ever.
Actually, we have one more.
Oh, so we got.
We uploaded our stuff. That was out of May about something, which I came late.
Actually, I can do it. Yeah. We can do it.
Bruce my head.
I can get that.
I got shot one time through a tire barricade. There was a little gap I was taking through it, and the guy shot me. And for thousands of like that, this phrase like that. It didn't pop. Oh. Actually, the thing is, I was in a like really wrong. I like you and like I managed to trust him. Like he was like, oh god. I was like, should I just jump in on the charge it? And it's like 2 hours to the pussy. So I just stood there and waited and pop back out like, oh no, again. And like and then when he did, I was actually just like down and like he could. Yeah, so yeah, you told us already, but I didn't. I didn't charge him. I don't know, like he's my friend. I would. Oh yeah, I'm not keeping pressing my friend. Yeah. But yeah, like I suppressed him and I did. And I got barricaded.
So, is that what we get to wrap?
Oh yeah, so you want to like
Is that the camera? That's the last one.
hey, so
Oh, yeah, you actually filming it now. Oh, yeah. Oh, is it live or is it
Like, it could be one
oh yes, here.
Yeah, I'm on the video somewhere. Oh, so okay. Oh, yeah, it's oh, did you register finish?
Anything to do.
That was from the but
Okay, I don't know. Maybe is that my oh, maybe. No, okay, here it's an open office to ask questions. Great. Alright, okay.
Is that what you mentioned?
They will give like I use it and in general. And then like you upgrade technology. Oh, actually one more.
That's it.
Actually one more. Yeah.
oh, they're like when it's like nearly close, nearly hit the bed, and you get they try to zoom in and like do the slow motion. Keep pressing.
Sorry, got the yeah, just here. Yeah. You really don't. Yeah.
The same time. How cool is that? But that's actually that's their design. That's false.
We get choose either slide design or your design drawer. This is yeah, so we'll just start up there. White model. You use paper and not this one. Up to you.
Wow.
It's making too often for do we have PowerPoint? We have no PowerPoint. If someone want to do the PowerPoint, please. We've got 1 more hour. All right. But now, yeah, that's my work. That's yours? Yeah. I don't think that's yours. That's my handwriting. Oh, this just does work. Oh, okay. Right. That's so creepy. Well, we're not going to use this, obviously. Yeah. I'm just like testing it.
Is this like the 10-minute presentation and the
And the 30-second one is due by 1:30, right? The 10 minutes one is due by 1:30, and the video is due on Thursday. But I'm not going to do it on Thursday. I'm going to do anything after the 1:30. If you like,
wait, so it's a 10-minute presentation at 1:30.
Yeah.
We're ready to work on that. Hey guys. Work on the 10-minute presentation. Is it live or is it?
No, it's not live. It's just us. It's just us.
Yeah. Oh wait. Oh, it's not film. No. I have to do the year right now.
however you are, then actually you want to care of someone else that's not me or whatever. Yeah.
No, it's on the way.
Yes.
Yeah, yeah. England. It's like that it's like the doing. And what type of this type will be one? I'm aiming to see this guy's an asteroid. Okay. My team is not.
I would say just outline the outlines.
Yeah.
Range, drawing, then vertical powers.
Why don't you go to YouTube and look at some of the
This one is the kind of stuff.
Yeah, that's what it's saying what could be, what could be, how much.
I can choose that bit.
Or we can say there's a can message and have like from narrow down to the one thing. Verify the okay, this is the best fit. Actually,
I'm not
here.
I can just say that I talk about it. But why not maybe and then
Well, if you can do it, then that's cool.
What?
Actually, do post editing.
Yeah,
Well, you want to first thing.
yeah.
You want to do it 100%?
Because it's 6 minutes, so I guess.
Is this a greater than or less than
So you can say, no, not you.
greater than or less than?
It's
Just making sure I don't want to stuff.
Yeah.
Yeah. I know what it means, but I don't know the word meaning. You know what I mean?
No, no.
I always forget if this is the less than side or greater than, but I know this side is bigger than that side.
Yeah, it's L. It's an L shape.
This part of the just is convention.
Yeah. I know the meaning, but I don't know if it's greater than or less than.
And that's what this thing. This thing greater than. Greater across.
Unlucky is right. Yeah.
It doesn't matter, you get a meaning, that's matter.
Yeah.
As long as you don't have to teach the subject, teach maths, then you're fine.
Yeah, and like, body only ends.
What they do, the academic doesn't work yet. They do the question, they write the question, and get like master student or postgrad student do all the answers. Exactly, postgrad.
Yeah, but also the drawings of the measure.
You actually use it for Flash.
We can use the background of that thing, but then just to remove this thing.
What are you doing?
Do you have like a actual white sheet of paper?
That is white. Increase the contrast. Yeah, bad boy. Increase the contrast of what?
Where's that?
So that is the break at.
That's white.
The camera settings. Camera.
What's that?
Doesn't really matter. Is that okay?
Is the light on? Hang on. I can just change.
That's the-
I can just change the direction of light.
We can give you a black background. Yeah, there. That's a perfect spot. Or do you want to just do it in one of these?
No, I think good lighting. So I was thinking of a projector as a light source. So.
You can go outside. That's
Yeah.
not a white background. It's raining though. Well, not outside.
It will be easy for me to actually do both.
Isn't black good?
Yeah, but you got. That's sample.
Yeah. Do you want a full view or do you want to just...
I'm set to sample, it doesn't matter the view is exactly that. So is it on there?
Yeah, it's good.
Wait back. Hey, give me a shoot it, photo. Give me a shot when you're actually doing it.
Okay, I got it. Press the wrong button, sorry.
Hey guys, give me a shot when you're actually like doing the presentation. Okay. So I want.
Do you want to go over there and then try again?
I don't know. I think it's a little wax. Hang on.
Do you want a white background?
Yeah. So we just stop motion on white paper. It kind of blends in.
Stand up on there. See what happens.
Yes, I'm trying to do is make it mix completely white. So you can stand up there.
No, just stand up there. See if if you're recording a white background, it's not going to be 100% accurate. It's not going to look that bad. Let's record. Let's zoom in.
Yeah. Don't like change the color.
The light was okay if I walk there.
Yeah, it's just pointing there. It's really actually bad because it's like rainbow background. Because the frame rate's probably really bad.
Oh,
yes.
Yeah.
White background.
Yeah.
Hey, Andy, I've just asked you to put more lights on the screen instead of projecting lights.
Yeah.
That might be better.
If it's normal, I'd be better because this.
So that it's like. Okay. It's not really hard, but it can't get any more on the screen.
Oh, these are the only lights.
Oh wait, can we put a PowerPoint up there and then make it white? Okay.
Why do you want a white background? I don't want a space background.
Huh? You can do green. You can do a green screen.
You want to use a green? You can do a green screen, like you can do a green screen. You want me to do a green screen? I don't know.
I think you just
Yeah, I tried a green screen. I'm not sure I edited the green screen, but I can find out. Yeah, sure. Try. Let's play a second video.
So what do you want?
Green screen. Change my mind.
Just make it a green.
Light green.
Oh.
No, not olive. It's more colors. More colors. Standard. Yeah, that one. There we go. Wow, that's green screen.
It's a F5. It's a little quicker. There is quicker, yeah.
Just try. Test, 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 test.
No.
Oh, yeah.
Yeah.
Sure, yeah.
Yes.
Thanks for coming. We got some other things to work on next time.
We need to actually present up there.
Well, no, it's you. Yeah, well, we need
Hey. Where's the camera? Oh, you can actually just do it here. Where's the camera? Can you see it? Just in front of us. On the ceiling? Yeah. No, I can't. Okay, yes. So how do we hook up our computer? Oh, you want to hook up your computer? Yeah, show the Gmail. This thing? Yeah, I think it needs to. You don't want it to zoom in. There's a camera here. Can we use that one? Else? Oh, here it is. We're trying to find. You don't want that. Well, does it show the other thing? Oh, here it is. Zoom in someone. Zoom in as jealous. How do I zoom? Cameras.
I think that's way too much.
Big Brother is watching.
Way too much.
It's pretty good quality. Nah. You see this? Yeah, I have to see when you see the screen. Just use that as the. Oh well. Let's see the tab. That's actually pretty good. Now, what website has this guy been looking at? Bookmarks. Ah, I can't see it. Oh, actually, you can just present it here and just record. You can just present it here and record. You can record the lecture.
Yeah.
No, there you go. Huh? Out the window? Sure. Out the window, right?
Enjoy themselves? I never enjoyed it.
Okay, that's pretty good.
You like trying to record people?
Yes, we can. That's been what have been used to record the live stream yesterday.
This.
Yeah.
This hasn't. It's we've been using the webcam right here to
Yeah, I
record the
know.
live stream.
Oh, is it
This is what the live stream is.
Oh, well, okay, then we could use this.
We could have.
We could have. So
We didn't.
We didn't.
Oh.
Select audience. Holy crap! Look at this.
What?
Right. That's pretty good.
It's pretty good detail.
Yeah.
Is that the closest thing up?
Holy crap!
Wait for it. Wait for it. Turn on the light as well. There you go.
That is so good. That's just what lectures. Yes, let's everyone look at your pores. Check this out.
That's really retarded. I think these things are the stupidest thing ever.
What's that?
Records the lecture. And a lot of them actually work. A roll.
You want to talk to this?
No, I want to talk to this.
Oh, crap. So yes, what we can do is just record the lecture. Just hit record lecture here.
A presentation.
Yeah, presentation. That's the way we can do that.
But it's a 30-second clip. Remember?
Not. Oh, we can record the presentation anyway. Just I have something to do.
Okay. If you want.
I don't know how to get it out.
What?
How do I get out? Okay. Bit dark.
It's bright enough for you.
Kind of zooming up the lights. Okay. Oh yeah. Okay. Oh.
That's just weird.
Okay.
Hey, wait until this part goes out. Then we go out like that. There. Now we've got the light. Then we zoom in the front.
What do you reckon? Okay, guys, what are you doing? Zooming into the light. It's just fast and good. Wait, change to this one. Let me go down.
You're a prick.
I'm an engineer. Don't worry.
You're an engineer. We're trustworthy.
Andy's trying to figure out how to use a camera and have a perfect spot. That's online. You can talk some sense into it. This is really fun.
Dinosaurs. Just love dinosaurs. Meteorites killing people off. Yeah, humans on dinosaurs. I love What? Yeah, that's so good. Well, I just typed in random crap before. Edit, go for it. If you think anything's wrong. Sound good. Hey, he's back. Find a good spot.
Actually, no, that's
I think we should. You guys want to read over what our project looks like?
Hey, so you got the this is the well, someone gonna do it. I think how we're gonna do it is try to just sort of like see what it's like. Someone gets you know what, I'll do something different. Then, well, each part of the presentation you can Good. You know what, I'll have to do. Sometimes it was we can do it something like how to going up like on calculation stuff and I think it's what's written on that wall. Which is what I wrote up on that. Yeah.
Literally, there's not actually a speaker. I have no way of getting it.
Well, you can explain how it works. So we share it with how to do that and how we can actually make this different expression of getting that in the page. And then we can talk about ideas how to get that.
Not on video presentation.
Not on video presentation.
Who got simulation on their laptop?
They're on, and there's on the, it's on Dropbox as well.
Alright, you know what, I'll use my laptop. Is that Gmail? Oh, right, yeah. I'm talking about Gmail, yes.
I couldn't say the same.
We don't know what to talk to. Yeah, I don't know.
Leo, you can talk.
Leo and Andy seems like they compete as well.
No, I said we split it up. I'll do introduction and conclusion, and someone else has to fill in the gap.
Andy can do that.
Or several people can fill in the gap. Kevin already volunteered to design of this grappling discuss.
Okay,
How we figure it?
Only we're starting on fact and then it's a coding this out to graph. It doesn't explode.
Hey. Then put all those whiteboard on a chair.
On a chair.
On chairs.
Or on a chair or chairs. And then, yeah, facing this way.
Why?
So I can use the camera and put it up here.
So you put it on the table and then you pass the tables?
No, I think it'll be better angle.
Because you can't put it on chairs without something on, like on it, so it doesn't fall apart. Yeah.
Okay, so in the presentation, should we have issue rehearse? Rehearse. Yeah, but yeah. Wait, does the
How's that?
when you go to the
No, you just like
Here, this is this way.
yeah, here. Yeah, I think. No, no.
I killed you, mine.
Yeah. Actually, basically.
Face that away. See how does it stay?
Yeah, well, someone has to hold. I know.
Yeah, holding people. I can hold it.
There you go. You're not needed. You're made redundant.
Yes.
What if you use it like pizza bits as a diagram? Okay.
We got a few guys to hold it. That's what we need.
Then you need a camera. Where are we going to find that?
Which camera is it?
Electric camera.
Is this going live still?
Oh, the one in the middle.
Probably. I don't know. Ask them.
You know, I can move.
Can you put it on the chair, please?
Where's the camera from?
Up there on the ceiling.
Sorry. Where is it? That's creepy. Where is it?
On the
Oh
ceiling.
wow, that's very creepy.
Move the chair, please.
What?
Move the chair.
To where?
You see the chair on the screen? Move that.
Oh, for that.
Hey, where's that squat down there?
No, you can move the thing back up.
Yeah, but we would go. Not do that, but you know. Wait, why do we need camera thing for?
Better show everybody.
Yeah, but we don't need a camera though.
But like I do want to present it here because so then I can use the simulation on my laptop.
Oh, okay, fair enough. Okay, I see.
So instead of walking back and forth, like walking over there and talking to the village,
Yeah.
and then walking back here to do the simulation.
Well, no, like, what you can do is like, are you filming it? I'll be able to film it. Like,
Huh?
if you're filming it, we've got a kind of camera. Oh, we don't need a kind of camera.
I'm not filming it. I don't know how to record.
I'll just put it. This is really fun. Should I move it?
Yeah. I can move it back later.
Maybe. Maybe not. Wait, how do you change cameras? Wait, how do you move it again?
Glowing both.
He's glowing.
Yeah, there is one piece here.
You're just gonna take a selfie with this?
Good. No, it's so weird. It's not even scary. I reckon we should rehearse it a bit.
I'm not gonna get mad at
Oh yeah, there's party out there. Oh, it's not. It's good to go. Yes, yeah, yeah. With everyone. I'm not sure. 4:30. When this finishes, yeah, pretty much when this actually, I follow that.
So have you got a graph? Do you have that?
That's one graph.
Yeah.
I think that's a picture.
Zoom out a bit more.
I need a mouse. Hang on. I'll get my mouse.
I want that to pay in your class where everyone saying what should be a video. Of course. It's like, if I've done it early, or you can get everyone saying this is our project, get chat, whatever. Yeah, I probably should after presentation. It's like storyboard.
Yeah, I think that
We can do it by Thursday. So if we get all the video done, you can upload it.
Ilya, do you know the order of the? You know the order?
Yeah.
The order of the talk.
Okay, so basically, I'll do an introduction. Introduction should talk about talking point of the board. Dan's going to talk about the calculation and stuff, and why is it explain why is it feasible. Okay, who's
Securities eating some pizza.
actually no, Ben will come later, a little later. Someone has to talk about the mission profile.
Yeah.
So whoever made this, talk about mission profile.
Oh, this. What do you mean mission profile?
So just point out, you can use the mouse, saying, okay, so Earth orbit is green.
Oh, just like displacement.
Earth orbit is green, so it's just say, okay, so
red is asteroid, orange is Mars.
Yeah. So, and then okay, you know what? I'll do the mission profile. Orange is Mars. Red is the asteroid. So basically,
red.
How to do it?
Oh no, go forward. Can you animate that? Oh no. Because if we can just animate it, then we don't have to go.
We have to run the simulation first. And it stops. Basically, I'll just say I'm going to do Hopman transfer to the asteroid. Grab onto the asteroid. Take an asteroid, take us close to Mars. Break that up, and then do some course correction to get to Mars. Okay.
Do you reckon that the simulation is correct?
Why are you putting it to 0?
Yeah, it should be correct.
Does it have time as well? Like, does
Huh? Oh,
states.
Yeah.
Oh, yeah, it does. Okay.
And they also got this stuff. When's it closest to?
Yeah.
Wait, isn't it a presentation mode though?
Okay, what is this? Explain to me.
Can't Ming talk about it? Oh, we don't need that.
I think you can download the new one from Dropbox. The one where you don't have all the stars.
Okay,
We just need. Oh, Ming can talk about it because I don't think he's talking about anything else.
yeah, and you can talk about the mission profile. Do you know what
Mission?
mission profile? So basically, we get from low Earth orbit, get to the asteroid. Asteroid take us close to Mars. And then from Mars we get to close to Mars. Then we break the tether to the asteroid.
Hey, can we actually use this? Don't bother.
Yeah.
Use this.
Whoever talking have to control this anyway.
No, but you can walk around and talk though.
I don't want to do that. Wow, such space. Bro, push up. Land party afterwards. I can play Battlefield 3 or whatever. Yeah.
No, I got Battlefield 3. I have Battlefield 4 as well, but this laptop can't handle it.
Oh, you actually have you Valentine's replay. Did you get MATLAB officially?
I did. From Stuttgart, they actually buy the MATLAB license for the students.
From where?
Germany.
Oh, really? That's fine. Hey, play safe. Let's go. Do you have any rocket setup?
I spent like a few hundred hours on that.
Have you reached dinner and stuff?
Huh?
Have you reached dinner?
Yeah, of course. I know. I haven't got back yet.
I'm playing for a while. But I've playing some building a space station. That's why I'm not really going to apply for it. I'm just building a space station in orbit. Yeah, it's like so far 5 parts. So.
I flew by Jewel. I've been to Jewel. That's as far as I've went.
You have a space station?
Yeah, on one of my copies.
Do you taste it? It's so hard to intersect it. Get the like a doctor. It takes like an hour, 2 hours.
Rendezvous? Yeah, that's what we were arguing about just before.
In this game, it takes like 1 or 2 hours. Like,
well, it takes like good 5 hours to learn how to do it.
Yeah, well, no, like you can just skip forward. It takes like 30 minutes for me now.
Yeah, I guess
to rendezvous.
The document itself.
Yeah, to on low curve orbits.
So anything it's whenever you watch sites that need ads to actually play, then you can actually turn it off. Like
yeah, well no, I haven't run into those. I didn't really watch video.
If you watch off YouTube, it's fine, but you go to the main website,
Yeah, but then
because they need the ads to survive. That's what.
But the thing is,
Ad blocker.
The thing is that website, like they screen the ad. So like they're not gonna have ads that are plain noise. Are they? Are they?
They have ads sometimes.
What's this?
Come on, man. Hey, you're back. We should really add your name to the thing. Have you registered this year? No, you would be registered last year.
Is your registration?
Yeah. My registration. You just said to register. I can do it now.
My scenarios.
Not doing all the jumping through this is way too fucking hard.
Dark backlight though. Dark backlight. This is our mission. We should say this is our mission. Heart of the panels. This is our 3D animation of our space program.
Yeah, that's called plagiarism. Well, we just have to reference.
No, we're using a software. It's Could we lower the price?
Yes, we can.
Is that control? We don't command center.
How to? Option.
Oh. You put the screen on, dude. Just do it backwards.
Oh,
What are you doing?
I know.
You'll see. You'll see.
Are you doing our simulation of what we're supposed to
Maybe. That's an asteroid.
You should actually put that in the background.
I'm actually
30 seconds. Fast move. That's it.
So space program.
Yeah, what do you need?
Fly rockets, still cabin.
I can't see what's say on the net ball.
You kind of had to add enable thrust moving away from it.
Are you actually moving?
Okay, it's not really as true.
I'll say it wasn't that expensive.
It's like $20. It's a really fun game. Good. Did you rotate the cameras? See the front of the. Oh, see that's the front of the.
Right, it's in now.
Dude, that's PG RCS.
I am on RCS.
Oh, you? Oh, sorry.
Wow, this is really slow.
This is what happens in space. That's really good.
Yeah, I know.
0.5 meters per second.
It's really possible.
Yeah, and we are actually trying to do it.
What are you trying to do? Crash and burn.
Can you do some 30 seconds, like at the point, like in put in the video? Like,
Huh?
do you have a screen capture on that?
No, I don't.
Do you download a screen capture?
I can, but
Oh, you recorded this, can't you?
I have no idea how to.
Is the asteroid moving?
Yeah.
Well, I can do this.
Your asteroid is moving.
What's
This- That's Kevin.
I mean, Kevin.
Actually, it's similar to an asteroid, yeah, but it's not the orbit isn't right.
What?
Sorry. HMI? Oh, yeah, you're pushing astro, aren't you?
Yeah.
Yeah, if you put it into a similar orbit, is what we need.
No, I just need to graphically capture.
No, I mean, if this is for a simulation, if you make it like the astro orbit similar to the actual real astro.
You know, no, I'm not gonna do that. No, we're not gonna do that.
But then, because then you pause it there, and then we have the video thing, and then just put that and then. No.
Okay, shit.
Yes.
I had it. Hey, what's our asteroid name?
2010.
2010, SF3.
And then what's the book guy? How you sell? Oh,
One for his person. But can you pause it?
What?
Pause it.
Why?
We can go and Google actually find.
So you technically traveling 400 and.
Could you actually find a video capturing app and just film the most?
No, we're not going because it's completely different. We're not actually rendezvousing it with it.
No,
we
but-
are shooting a missile and try to hit it while you're on the moon. This is best case scenario. This is what we're doing.
Why don't we just do that?
You weren't dead. Good. We just do a
The
rendezvous.
amount of fuel that will cost to do it
You will not be worth
is
it.
not worth it.
The only way to make this work, make capturing asteroid and letting us work, is actually catching it while it's faster than us. Or faster than the rocket.
Okay. I understand.
Now you're just hitching a ride.
No, I'm pushing the asteroid.
Crash it to Earth.
Pushing the
Crash it to
asteroid.
Earth. Crash it to Earth. Okay.
Stop it! Go! Oh no!
Is that a logo? Is that our logo?
Dude, you think you know? I don't think so. You did it really early though. You did your burn really.
I don't care.
It's like 3 hours to burn.
So.
I tried to hit Kevin.
I think I did.
Huh? Did you?
Maybe not. Shit. Where am I? Can't see it.
In the blue line.
Yeah, but where am I on
it? Let's see. Him again. Ooh, damn, look at that glitch.
Shit.
Press the information icon. Sorry, look right. Look right up. Wait, is that passenger over there?
Yeah.
It didn't show up. Shouldn't show up. You ready to talk, guys? I don't know. Wait, we actually do. Which is.
I'm still so amazed by the quality.
We're gonna buy one now? What on earth are you doing?
He's trying to crash the asteroid to Earth or Kerbin in this game. Did you want more pizza?
No, I'm fine. So, are we ready? Or...
No. 2:30. Like,
2:30. Oh, 2:30.
Yeah, 1:30 you have to have it submitted.
Oh. Submitted how?
Online.
We already did that.
Okay.
Okay.
Wait, how we
still change it after 1:30 or?
Yeah. You have to, because we have two teams.
Yeah.
You're both nominated for something. Right. So you have until Thursday to upload, change, whatever. And after Thursday, I think all of it's going to be locked out. So you have until then to put everything forward, to put the video up, to do all the rest of it. All right.
Hang on, so. Wait. Yeah. I have a brave part, I could part right now. Like, what was I gonna say again? But yeah. Sorry. What do we upload for the what do you submit it?
We did our GMAT file or what do we submit? Like our references. Our description.
Okay. Do you put the whiteboards up as well, like pictures of the whiteboard?
I don't think we actually did. We get the whiteboard?
Well, the PowerPoint?
The pictures of the whiteboard.
We got two of them. I don't know about the rest because I don't know which ones. He said two of them were complete, and the rest I don't know if they were complete or not.
Ask Ben. Get.
Can you trust me?
Huh?
It's a pretty high definition video.
Yeah. A little bit lag though.
Check out that line.
Tokyo Deep.
Yeah.
Is it on the focus? Oh, sorry.
Wait, what are you doing?
Oh.
That's some pretty good quality.
This is the microbacterial life.
I know.
Where is that? Oh, wow. Hang on.
You can see your
That's that one.
Whoa,
Wait.
Wait.
I just make this fingerprint.
Yeah.
Whoa, what is that?
Oh, it's gross.
This is disgusting. Why would you do that?
It is a microbacterial life that we live in our home.
I'm using
I
this
needed a
one.
moisture rinse.
Whoops.
Whoa, man.
Sorry.
Now no one can see. You have to do
2 images.
3 images. Pick 3.
3. Oh, you can hang through 200.
You have to tap numbers. Yeah.
Changed it.
That's my one.
This should be like the new.
Click the third one. Pick.
No, you need to have I'm gonna import that. Can you turn that up proper? Go that straight or
No, this one's working before.
How is this a functional lecture?
Oh, sorry.
Yeah,
It's not. It's a
I
forum.
think video con one. No. Oh no, that's everyone.
How do you get back? Oh, sorry.
Lecture cam.
Is it
Bottom right.
on a VGA cable?
I don't know. Do lecture cam on the bottom right.
Yeah. Click them all.
Yeah, click them all.
Oh, yeah.
Look.
No, the camera's based on this one then.
And it's pressing up there.
You push that up then.
No, that's what I'm doing.
That intense gamer face.
Hey. Mucking around.
You don't get to muck around this, you know, when you're in lectures. I mean, this is fun.
Yeah, I know, right?
Intense. Oh, it's the closest. Can you go closer? Intense face. That concentration right there, man. Come on. Like, that concentration.
Hey man, I'm doing an orbital maneuver, doing a correction bed. Serious shit.
I think I've uploaded everything up.
Alright, good.
Cool.
Cheers, man. I have a check up.
Oh, wait. Did you include this?
You want to pop it up there? Just this. Yeah, it's really easy. Let's just take picture, upload.
Can you put a picture of pizza, I think? That deserves credit. The pizza deserves the most credit.
You should live stream it. Oh, it's a live stream.
It is a live stream.
Just that intense gamer face.
Turn this off.
Sorry? Yep.
Yeah, packages. Oh, we can see. They record sound. Well, not record. Audio out sound.
What, you want sound?
Yeah.
It would hurt people.
Better turn the microphone on. Oh, okay.
Start teaching them engineering facts. So we say you're
Cool. Oh, we got another hour. Is this still live streaming?
Probably.
Dude, is this actually still live streaming?
I don't know.
Maybe.
It was live streaming yesterday, but
Check YouTube. YouTube.
we've been like
Yeah,
fidgeting.
your hair is messy. Whose laptop is this?
Oh, well, yeah.
Oh, Stan.
That dedication face.
I'm trying to! Correction! Leave me alone!
Yeah, here's one story called the actual third video that's going to go around the world. I mean, I guess if it's global, we need to separate to it. It's good NASA and global. Miniature effort is some of the fire.
These guys were in the world. Check out these guys.
We were by people. Well, they must be good. Coming fast. People's choice.
People's choice award. Sounds like Nickelodeon. People's choice
Yeah, I
award.
know.
We could actually, since we're in the Brisbane River, we can actually do a scene that's outside. It's raining. Welcome to Brisbane! Yay!
But do you actually want to do like a good quality?
Yeah, but I think
Just, if you want to do it now, do a good quality one. You have to do it tomorrow.
yeah, it's right.
Because we can't meet up before Thursday. Unless you want to get the images now.
Yes. No, I'm doing post editing. I'm up to date.
Oh, okay.
But I'm not sure. Can you put it on Dropbox?
Where do you put the videos?
Onto YouTube.
Yeah, but you need to link it somewhere.
To YouTube.
CP's account.
Yeah, if you put on my account, it's easy, and then we do need to put like a. Because how can like, they see it? Like how do they?
No, because you link it up to it and then it will have a link off your project.
Oh.
Yeah.
Well, I should actually know this.
Come over. Oh.
It's just better.
This is what happened. So we got our name is just try that. This is the description of it. And then you get a license and source code. And over on top of the software will be a video. What is a video? You just get like no wherever you choose. You can upload it as Dropbox in your catalog. Anything like doesn't bother me to have like 50 gigs of Dropbox. Do that? I've got no objection. Well, you're allowed to use 10% of anything. If it's 10%, you can use 10% of things without reaching. 3 seconds. You just put the first 30 seconds. Like video is wait. So the video what? Is that all? Doing. Back in 10th day, we're faced with it. Yeah. Stressful. You know, without the maneuvering modes, what a game. It was a lot harder to actually get past. Yeah, we actually had Whoa. Are you wasting our LCS?
Yes, maybe. I'm trying to find my thingy.
What can I find?
My
Screen.
my thingy.
What thing?
My blue thingy. I don't know where it is.
Your center point mass is in the middle. Oh,
No, you have no manipulative. It's go down. It's in the orange zone.
You sure?
Oh, and it's top. It's in the north. Go north. Actually, yeah, up. Blue zone, blue. That's like 90 degrees to the north part of the zone.
There you go. Oh.
Yeah, because you're doing a overload.
Plenty. Don't worry about it.
We'll probably have a startup Space App Challenge 2014, and then our project, mission. Yes.
Hey, so who said they want me to crash the asteroid into Earth?
That's the whole day
Hey, Andy, you said you want me to crash the asteroid into Earth, right?
Do it during the video.
Oh, no, it's not.
Just use the Space App Challenge app. It's just logo. Use that. Change colors this year. That's fine. Yeah, that's good. Yeah. So after this, you could actually come in and say, hi, this is whatever. And we connect. Yeah.
Whoa.
Yeah, it's never been 30 seconds. Yeah. Yeah, 30 seconds. Yeah, we have to. That's why. It's 30.
We don't do this
So now it's 20 seconds. Alright, how about we just hey, we are able to fly.
It's like highway. It's highway hitchhiking, trying to mods. Is it? Change mods. Mods.
Oh, fuck. What? No, I got a planet course. I got a planet node. I need to complete the planet node first.
Why is he moving? He's not in the center of the video. It's CD. He was in the middle.
You must be in
He
the.
centered it, and then he moved. There we go.
Jesus.
It's tense, man. Oh, now you're moving. What?
There we go. Oh. Zoom out a bit, and then we get him.
Yeah.
Get him.
Working guy. What did you do? Whoa.
There we go.
What's the president? I don't know.
Alright, 1 minute 40.
We have like 3 seconds of future.
Oh, no, yeah. Yeah, okay, so still 2 more.
You can still put it. Nasty it up.
Yeah, I like that. I like that. And the color of the hair, that matches.
You guys got the assumptions there. Yeah, we do. Just saying that we made these confused.
It's just essentially only friends that will. A few weird things. People walking up to it.
Do you have your presentation on the set it up on the PC?
PC or
Or are you gonna set it up on your one? Yeah, it's alright.
Well, no. What we're gonna do is that we're gonna project out onto use.
We can have three screens. Yeah.
Yeah, use the camera to get because most of our presentation is actually on the whiteboard.
Okay. Yeah.
The only thing that I really want to present using the laptop is
that software. Yeah. Okay.
And the
And
drawing.
document the camera. Okay. So you're gonna come up here with the
yeah.
And show on that screen. Yeah. Yeah. Okay. Alright. Done.
How much time do I have?
Is that a half hour?
Alright. I can crash the asteroid into F's at that time.
Is there more white there was some yeah.
And then
And why talking pretty time? Someone okay, the benefits for that would be delta V and then the energy for the session was Luis and the G map. We're showing how.
You can probably have that in the background while we're doing it.
Yeah, but I'm talking over and it's yeah, so you can use it. Yes, that's using yeah, that's not to be expected to reduce and be
Suppose how much time is spent in this meeting?
once he crashes the industrial. Is that
We get bored that give it 1 second.
yeah, no, it's fun. Stop this
There's actually a part to it that'll get interested, but if it's just looking at one of these screens for like 30 minutes.
No, it's actually like
and that's
really hard. It's very available on the moon. Land on Mars.
5 to 6 hours. 6 this morning. That's the OS. This was yesterday. So it was up to say that it's like terrible. It's like let's see if we can go up today. This guy. Yeah, let's see if it actually focuses it up.
Oh, it's only 2 megapixels.
Only 2 megapixels.
Could you make it like a table for the website? Yeah. Could you make it like a show? In like, I'm just going to we can bring it up on the website. Yeah,
I think they've set it up to be like that.
I'm doing more ways, like,
Yeah, just like one by one.
Exactly, like you can make a program to do that, but that's another thing. Yeah, I mean, it's And what I was thinking was that we do a video capture of you just scrolling down the table, like 2 seconds, right? And then that's over the actual video. You scrolling, but I'm talking over that. So like, there's so many asteroids in this area.
Well, it's easy because the way it's all
Yeah, but I was very interested in a video capture of these trees. Just scrolling down. The video capture. That was the video capture.
Leo.
What?
No, that's the right one.
Probably stand up video.
Hey, so guys, I'm not going to use one platform. I'll say, key. It's the Facebook video or the image for Brisbane. Video is for it's our UI, it's our project name, it's what it's about, what and then I'm just going to pass it on to the next person. Yeah, maybe. I think that's you said. Actually, no, that would be me. Me will be second. You will be second. You will talk about the mission profile. Okay. And then all the presentation. What? You also will actually why the reason? Why? Well, no, you are doing all the whatever you all the calculations you need to prove that it's what do you need to make your point across it?
I guess like you got you got speciality and
Yeah, that's
something I got.
Cover it up. You should cover up the screen. Webcam. A minute ago.
Oh yeah, that's fine. I didn't cover it up.
Just tell us a nice background question. How do you hide things?
I didn't cover it up. I didn't do shit.
Yeah, okay, yeah, I walked up to the screen. Press the hit button.
We still, is that Australian?
No, this is. Well, no, it's not. I said like, when we hit that, go on. Go retrograde. Go retrograde. Go on. Hit F2 again and then retrograde. Yeah, but then if you're on. Okay, back to this. Yeah, the does is Oh.
So each verse goes down what we did, so we showed that game map and stuff on the screen that our people is showing. So if you just oh,
So we wanted to do that. And this. It's finally walking up to it. That's more than anything. That's more than yeah, I don't know. I'll be standing next to you.
Yes. But I can't be my
You're saying say
we will say
Oh. Kevin. Kevin.
Yeah,
Yeah, you're going to come up the bed. Up the bed. And from 10 to 6. Okay, you come up the bed.
Oh, okay.
Then you come up the something you use. And that's something you make.
And then Kevin, you're gonna speak up the bed about the graphical house. And I'm going to come back again and say conclusions. Well, first of all, future future application, like beyond what we discussed, some more like stuff that we can be beyond what we discussed, and then thank you. No, they concentrate on. Actually, okay. So what's the order?
Just have
me first. Who's next?
We don't actually need everyone to talk.
No, no. Me.
It's just the judges.
Wait, hang on. I put the order. Who said? Who did I say second? Who's second? Who's third? What are we talking about? Second. Then Kevin fourth.
You don't need to talk for the presentation. We're doing this.
Yeah, you guys do the video and us. Just put in there.
Picture the video. That's gonna be difficult.
Yeah, okay. Hey guys, team video.
We get some of the
But I want to crash the asteroid.
Even if I made it
Huh? Yeah, because I'm at the where am I? I think I'm at the before the yeah, it's an eccentric orbit, so I'm at the epilepsy. Well, after the epilepsy. No, before the epilepsy.
You're gonna speed up slightly.
No. Fuck no. I'm gonna crash it.
Before or after?
Like if I'm decelerating, then I must be before the apex. Yeah. Yeah.
Well, are you still decelerating? I thought you started speeding up.
Is it speeding up?
No, no.
No. 0.6, 0.5. I'm still
It's
decelerating.
inconsistent deceleration.
Oh, because I'm actually burning LCS. And I'm gonna burn retrograde.
Oh, you're actually gonna try crashing?
I'm actually gonna crash it.
Does it bring you joy?
Yes. Okay. Oh, final return. 70. Oh, gee.
What are you doing? He's crashing it.
I can't even see it.
Is it slow enough?
It's like slowly gonna crash or just
Actually,
crash.
it's gonna air brake first, then crash.
Oh, how accurate is air brake? Can you make it air brake with the rock first?
Yeah, I'm doing that.
Reposition.
Come on. The aerodynamic system is not really good. It's very simple.
That would be silly. That's a lot of time and energy.
It's good enough for the game.
Yeah.
I never crashed an asteroid before. I wonder what will happen.
You're gonna crash it on land?
Not sure. I'm not sure what I will land.
Do you have control?
Yes, but I have no idea. It doesn't show. Doesn't show.
You still have 100,000.
Yeah, well, I'm at the
Already?
Well, he is fast forwarding.
Yeah.
Hey guys, do you want to do a video before? That freeze. Hi, we are a team. Blah 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 blah. Okay, 3 seconds.
Okay, tell me what do I have to say?
Hi, we are team Hitchhike from Hitchhike.
Guys, make guys.
Yes, tell me. Why don't you write down? Write down what I have to say, then I'll say.
Hitchhiking to Mars.
Hitchhiking to Mars.
Yeah, the hitchhiker's guides to Mars.
There's no guide.
Wait, you guys changed your name back, guys.
No, we already told you there's no guide.
Everyone, so we're just gonna get everyone to sit here and then look up while we're like stand.
Alright, it's hitting essence here. Oh.
Oh, are we burning?
Well, its atmosphere in Kerbin is 70 kilometers.
Time warp 3. 6.
That was really a silence.
600.
Can we put the computers up there? I'm gonna set these up.
Hello.
I know who's up there.
That one.
Oh! You know what we should do? You know how you get the picture of them like typing computers, right?
Yes.
Right?
Whose laptop is this?
It's place TT's.
That's
Hey,
mine.
Houston. Hey, Houston, is it Houston? So that's right. You can leave that in.
I just put that.
Where's... Full power. Pull that power brick. I have an idea. Stop the video. Yeah, start typing into the pizza box. There's a comedic value. Like, come on. It's like a short clip anyway, like 2-second clip. We have people on pizza boxes. I mean,
If that's your direction.
Yes, I'm doing that. Pizza boxes.
Yeah, I probably would not look at, or wouldn't watch the end product, so I don't really care. Ah, come on.
This time warp times 100.
You can't not loyal, but we're trying to do. You guys crash it.
Yeah, I'm still haven't reached Perry Epsi yet.
It doesn't matter. You can just decelerate. It doesn't matter where it crashes.
No, I know, but I'm just saying you haven't reached Perry Epsi yet.
He wants to decelerate it.
Already.
Are you doing air braking?
Yeah, I'm already under.
You don't need a fuel anyway. It's, it's only a nuclear fuel engine. It doesn't matter if it crashes first.
Well, no, it should be in a terminal dive anyway.
Sleeping?
Yeah, it's in terminal dive.
Oh, right, okay. Yeah, it's air braking. Cool.
Oh, is yours on the HDMI, is it?
Yeah, oh, you went as well. I just need it when I'm doing my presentation.
Okay. Yeah, that'll do. We'll switch it out.
Yeah.
Oh no! Solar panel. Hi guys, it's a Gmail. Oh, Gmail. Yeah. Yeah, this will be the computer. I like it. Pretend you're a pizza. You guys have extra mouses in that? I don't think no, you just put in typing code and something. We need one more person. I don't have to be serious. Pizza? Yeah. Yes. No, the typing on that. Okay, just sit there for a couple. There's one more mouse here. There's a mouse here as well. Yeah. No. Your phone's open. I have the button in front of it. Yeah, that's what I actually. No. Oh, no, I put it in my video. You should look over to history and like look over to the library, right? Yeah. I'm pretty one second. You look for explanation that's already working tests that like 3, 2, 1. Oh, back to my. It's like, like ripping for we should have that picture as well. Oh god. Did you get extra points for that? Yeah, actually, no, we should. That's right. Yeah. This is how intense people doing GMAT. wait. Yeah, that's a video clip for here. Alright, okay. We need to do a team. What's sort of
With this parallel, it's so nice. That's good enough. As long as they can read it. Yeah, that's good enough.
Look at our cool diagrams.
This is you're supposed to do that team thing now. Team name. You got the hitchhiker too. Yeah, the official name. You got name.
Duh, it's not that.
Hitchhikers, we are the hitchhikers in Mars. We are the hitchhikers in Mars.
Yes.
It is kind of. Yeah. Why is hiking? We are the hitchhiking guys.
This is the
We are the. Hi, we are. Hi, we are from Brisbane. This is a hitchhiker. We say that. Hi, we are from Brisbane. This is our hitchhiker's guide. All right. Hi, we're from Brisbane. Right.
I have questions. Didn't get destroyed.
Still there. I crashed it. Yeah. Just so I can tell.
Wait, what? Did you have a new getting started? Did you apply for it?
Oh, you didn't get destroyed. Yeah.
Let's do this one.
What happens if you land on like land? You destroy the world then?
It's more explosion.
Yeah. You get it. Can you like get one planet?
That's your
Okay, so just log out of it.
I'll just open the in private window, can I?
Oh yeah, yeah. And then, yeah. That's okay.
What happens if you like 10 billion?
What's my password?
No, they are on brand. Just for them. Yes, go on. Tell me what to say. Hi, we're from Brisbane, and this is a hitchhiker's guide. Hitchhiking.
Oh.
This is the hitchhiking guide to Mars.
Otherwise, hook up your laptop. We can hook up the laptop.
We're from Brisbane.
Hang on, oh, it does work.
Hi. We're from
Or maybe I can export it to the PDF.
Mhm.
It does work.
Hi, we are from Brisbane. This is our hitchhiker's guide to Mars. Yeah, everyone says it.
So I just. No.
Sorry.
Yeah, it's a bit hard.
Maybe it's just a combine. Is that a
It's the HDMI and I got VGA.
Okay. Where's she gone?
Do you want
I think I need a
Oh, you need the plug.
Yeah, maybe I will export it as PDF and open it again.
Okay, yeah.
Yeah, can you just leave the window there?
Was it? Do we want to do it now? Hey, Stratos, could you film something for us?
Yeah.
Like this is
1 and 0. 1.
Us.
Guys, everyone, over here.
And if we screw up, we'll just do another take without cutting it. Guys,
Guys,
stand up and just sit. Yeah.
sit and stand, whatever.
Are you going to like
end the video?
Yeah. Okay.
So we're saying, hi, we're from
Hi, we're from Brisbane. This is the hitchhiking guide to Mars. Yeah, we'll probably need quite a few takes. Yeah, if we fail once, we'll say stop and then start again. And are you ready?
Alright.
Ready, when you say just go. I don't know
the press the red button, not the camera.
Oh. On count. I'll start it, then you can probably pop it out. Okay. Yeah, it's going.
Okay. You want to count us in?
1, 2, 3.
Hi, we're from Brisbane, and this is hitchhiking guide to Mars.
I think we'll do it again.
Do it again.
Yeah.
Hi, we're from Brisbane, and this is the Hitchhiker's Guide to Mars. Alright, one more.
Yeah. Okay. 1, 2, 3.
Hi, we're from Brisbane, and this is the Hitchhiker's Guide to Mars. Right, okay, I think 2 is good. We have 2 is good.
Thanks, Mel.
Awesome.
What else?
Yeah. Yes, that's good. Oh, yeah, no.
So I got the PDF file. You can open the PDF file here. And presentation mode, view, presentation. Yeah, it's good. Oh, looks better in the projector.
Still the Kit Kat thing as well. That's awesome.
Good.
Yeah, I mean, like that actually includes our sponsors on. That was good. Okay, so we got.
Includes web browsers, everything.
Yeah.
That is actually really good.
Yeah.
Yeah.
Okay, so I need to film.
Okay, so we'll kick off in a few minutes. Is the mic on? Maybe not. Maybe not. Audio source.
You just need to record.
Yeah.
Can you just record that?
Yeah, and record the video.
Yeah, just say that.
I don't know, we need it.
Yeah, you can just
Yeah.
to record it.
I don't know how much science purpose do it, like.
And it's like cardboard.
Oh,
This is cardboard.
yeah, but still, like, do it the entire day.
Pretty light.
Oh.
I'll put it all right.
And it's like the most immediate job there is.
So if you want to film it, you want to play all the time.
Okay, if we take our seats, gentlemen. Okay, so what we'll do now, we'll kick off into the presentations. So thanks, guys, for working hard the past weekend. We can still continue to develop these challenges and processes over the next couple of days as well. So by all means, continue to do that until Thursday, when the final challenges will be cut off and whatever's left in there will be submitted through to the area that the judges so choose. So I've got up on a couple of screens here our judging criteria, or the judging areas. So we've got best use of hardware. So none of you guys are using any hardware for this time. But we've got best use of data, most inspiring galactic impact, best mission concept, and people's choice. So the judges, I've just had a quick look through some content that's come through from the international guys in the States. And so what we'll do, we'll nominate our teams in these areas. The people's choice, they've said to give it up to the contestants, and it can be a second team nominated. So one of the teams here will have 2 nominations, one in the category and one in people's choice. All right, so you get 2 chances to try and win something super special. Yeah. So later on, so the judges we've got here, we've got Simone at the back from QET. Hi Simone, thank you. So she's coordinated a lot of the work here, the room booking, the environment, the Wi-Fi, all the food. So thank you, Simone, for all the food, the room, everything here, QT, thank you. And hopefully we can continue to keep this relationship going in the years ahead. Yep. We've got Duncan. Duncan's from the planetarium. So for those of you who attended the talk last night by Jen, our NASA representative, Duncan and Jen provided that quite exciting tour of our solar system and asteroids and near-Earth objects, and how we might mitigate against any
potential collisions or potentially hazardous asteroids. And we've also got a guest all the way from, well, from Brisbane, but should have been in the Gold Coast, but we'll take him anyway. So Michael, we've got a spare judge, so he'll join in and he'll provide some input to the teams here. So with the judges, yeah, we'll go by that. We'll let the participants choose a people's choice, and we'll do that right at the end. So I'll get you guys just to choose between the top 5 at the top there. With that, maybe we'll start with the first team here, since you guys are the closest. So if I get you guys to come up, we'll hook up and change these computers over, and you can present here.
Ben, Brett, hold this.
Where do you guys want to stand? Do you want to stand there?
Bring a mic over there. No, we're going over there because I need.
Come over here, yeah, and do it over here.
Yeah, I can control. Okay, sure. I control it, yeah.
Yeah, yeah.
And then you can just bring a mic over if you want to talk with the mic.
That's all right. Let's do the guys here.
Okay. Because you're pretty far away from the judge.
So they can see everything.
Yeah.
Go over there. Both people have to be close.
I need an HDMI cable.
Yeah, it's there.
You got the stuff though?
Yeah, so
slide. So then the mic for the questions. Okay, hold up.
me.
Yeah.
So you had to tell Ben, you know, constellation. How do I delete from stuff? Okay, so you had to tell Ben who will be controlled from here. When you want to play it, which graph you want to bring out. Okay.
Yeah.
And then you're gonna talk about first you have
Does
to.
it have the graph?
Huh?
Does Ben has the graph?
No, the graph's here.
Oh, but wouldn't Ming be here talking about?
No, Ben will be here controlling. So you have to tell Ben like
Oh,
next
okay.
few seconds.
Yeah.
In the next 30 seconds, what you want from him. Okay.
Yeah.
So just tell him that we about the asteroid. We just look through the asteroid from our references, and we found this is most probably the most appropriate asteroid to use for our scenario.
Yeah.
Okay. Just that, and then you talk about, you know, well, when it's closest to Earth, and then you talk about how, like, when we will fly to the asteroid and when we will fly. You know, just use your best judgment. Okay.
Alright, whenever you're ready.
Yeah, sure. Ben.
Yep.
The Ben's gonna be here, that controlling the computer.
I think Ming should be doing it.
Well, they wanted to be there, so.
Because Ming can see the mouse and you can see.
Yeah. All right. So, then you tell Ben what you want.
You guys are.
So I'll just be here.
Yeah, present.
All right, you have 30 seconds.
I don't think
to
Ben
explain.
knows how to use it. Yeah. So I think Ming should stay here.
Should we-
Because Ben doesn't know how to use it. And
Yeah. Okay. All right. Fine.
What do you want? Ming, you want to stay here?
yeah, I think
Make more sense. And you can talk over there because you know what you're doing.
Oh, I'm talking.
Yeah, just get rid of the Space International and get electric camera over it as much you can. And then zoom it into you.
Okay, no, that's good. Okay, here.
But this, should we set it back to...
Here will be the dot cam.
Should we set this back to the...
Okay.
Yeah. 30 seconds. Okay.
Alright.
Yeah, 30 seconds.
Are you starting?
We are starting now?
I thought he's doing the intro.
You got 30 seconds.
This is my what?
Oh, no, you gotta turn
Yeah,
it.
it's totally.
Hit mute.
Mute.
Yeah, that should work now.
But I thought they are doing the intro.
Yeah, there's one intro.
Yep.
Yeah.
Go.
Okay. Right. So, hi, my name is Leo, and I'm part of the team for the Hitchhiking Guide to Mars. So, the challenge we have done for this for our presentation is design our own asteroid mission, and we chose to design a mission to use an asteroid, to capture an asteroid, and use that asteroid to go to Mars. So our aim is to demonstrate that an asteroid can be used as a aid for orbital transfer to Mars or any planetary system. Okay. So our hypothesis is that it will reduce the transfer impulse required in an orbital transfer to get from Earth and to Mars. And this concept can be extended to Venus or other planets or other sources of objects. So Ming over there will now demonstrate the mission profile and yeah. Ming?
Alright. Okay, so basically we can see the orbiter of Mars, Earth. The green color one is Earth, and then the red color one is the asteroid, and then the orange one is Mars. So basically we'll get on to the asteroid when it is the closest distance between Earth and the asteroid, and we'll get off from the asteroid to Mars when the distance between Mars and the asteroid is the closest. So here we have the displacement graph between Earth and the asteroid and Mars and the asteroid. The one in green is the displacement between Mars and the asteroid, and the one in red is the displacement between Earth and the asteroid.
Now, some of the assumptions we made with that were that there would be a regular point that the asteroid and Earth are relatively close together, as well as a regular point that the asteroid and Mars would be relatively close together. After we had run the calculations, we actually found out that the asteroid is by it's back to the other window. Has got quite a bit too far a distance. The asteroid doesn't actually make it close enough to Mars anymore. But we decided to keep running with it as we just proving that it's you can get on it is plausible. So from there you can see the rendering of the asteroid is still quite away. We've also made assumptions that the asteroid is a solid object, it's landable and it's not going to break and deteriorate when we land on it, as well as we collected other bodies such as Earth and Mars and any other orbiting bodies like
Three. Yeah. Okay. Can you hear me?
we talk about advantages of basically trying to provide 20 hours of Earth and Mars is that it's faster because asteroids travel faster, and also that basically it requires less delta V. Usually with Mars, you use delta V from 10, 6 kilometers per second. But when you factorize an asteroid, it basically goes down. And also the graph, I do believe we found out that it takes significant amount of time to provide, so we a lot less. I think it's 60 days. Yes.
Yeah, it's around 60 days.
Travel asteroid. So that is pretty amazing. It's hard to write that out. It's about 60 days, which is a big improvement. should, 6 plus 8 months to take per Mars. Less human stuff, and then basically cheaper, higher more stuff, cheaper, and it's faster. So it's possible for humans. And then our concept is that we've demonstrated the unmanned big distributed theory, but for unmanned flights. And there's also many other asteroids that have a similar trajectory or orbit that go between Earth and Mars. So this can apply to all these asteroids. So instead of waiting for one particular asteroid as a hitchhiking ride, there are many other asteroids in the field that apply.
Go back to Kevin, who would talk about the traffic system that we use to capture the asteroid.
So of course, when we send a rocket to the asteroid has to somehow attach itself to the asteroid, otherwise it's not going to go anywhere. We found out that delta V, difference in velocity, is about 1 kilometer per second, which is really fast. So if we somehow just attach this to the asteroid instantaneously, then everything inside the rocket will of course break apart because of that impulse. So we have to somehow attach it and then slowly accelerate to the speed of this asteroid. So we've come up with a concept of maybe putting a homing device in this harpoon. So when it shoots at the asteroid, it'll target to it and then reach it. And then once it hits it, these claws will come out and actually grab onto it to properly clamp onto it. And the ropes here will be attached to the rocket. So the rope would have to slowly, what's the word? Lengthen. So otherwise, it'll just tug and just pull away. So, yeah. We found out that if the maximum G force that the rocket will experience is about 10 G, then the maximum brake force required is about 1.7 meganewtons, and at least 500 meters of rope would be required for this to be successful.
Okay, so basically with the shuttling units, that of course not many current material actually exists. It's measured 5 volt to withstand that kind of force, just to get. But this is of course for future missions and perhaps new material will appear. So the point of this mission is to only not to rendezvous, say, dock with the asteroid, meaning that we then actually try to match the optical velocity on the plane. We just aim to do an intercept, and then hopefully the intercept will bring it close enough to the asteroid, and before we shoot the harpoon and capture the asteroid, and use the asteroid to drag spacecraft toward Mars. Okay, so beyond the scope of this conceptual mission, there's also other future application. There was a paper called, I believe it's hitchhiking to, no, it's I can't remember. Yeah, use NEOs to travel to Mars. The paper states that because the high dose of radiation for that spacecraft was experienced, so shield must be deployed, or an active measure, or other passive or active measure shield have to be deployed in order for any human to survive the flight to Mars. That paper states that it's relatively feasible to use the asteroid as a shield. instead of building one on Earth and sending up to with air spacecraft. So that's one possible other application to this mission. Other possible possibility of this mission is to harvest material from the asteroid while en route to Mars, say water or hydrogen or other fuel to use as further down during the mission. To conclude, we have this team have developed a conceptual mission that will use an asteroid considered A to fly to Mars, which should limit the amount of fuel that is needed to go undertake such mission. Thank you.
Thanks, guys. Let me just unplug this.
Rich.
Yes. It's okay.
We're gonna put back the what do you call it?
Oh, I see.
Yeah, so just get one.
Well, we can hear you.
All right, you can hear me. All right. I don't know very much about delta V except when it means, so I take my hat off to you who are considering concepts and calculations and so on that my fellow Dr. Michael here might be more familiar with. What I did notice is that you have the orbit of Mars and the Earth. The way around the asteroid was a retrograde asteroid. Was that a particular asteroid you chose?
No,
was that accidental?
Yeah, that was an accident.
Okay.
All I know is that too.
Because that's the other thing.
All of them are supposed to actually go the same way.
Yeah, all right. That was a major question of the way, and the fact that you said that you apply this to other asteroids. I guess from what little I know of flying space missions and the dynamics of getting a spacecraft into another orbit, or to match an orbit into another body, there's quite a bit to it. I know it's, or I believe it's trickier to go into the solar system, so we had to get him to go around the sun several times before it could match its speed. So is Mars going out, or is therefore an easier thing to deal with?
Well, in that respect, it's also positive factor.
Yeah.
So this we have an asteroid complicated, right? Yes.
Yeah. So you discussed the concept of this stretchy rope. I'm having an instant vision of a big bungee, and that then makes me think you attach it, and there's a sort of delay period, and then suddenly your spacecraft goes going.
That's the ideal situation because you can send the amount of time the force is high, means that the change in force is less than what it would be. So I think we got an approximation of about 1,000 meters per second, so the change velocity by 1,000 meters per second. Right. 2 meters of the So by extending the amount of time that we're going to change another view, then it can be more of a doable.
Okay. I guess my concern is how controllable is the end result once it catches up and you then go to catapult.
It's more yeah, that is ideally to catch up speed and then move and then track the rope so that it's so what happens is that at the end of the flight with the asteroid, right, when the asteroid is closest to Mars, the spacecraft will untether the asteroid, and hopefully that there will be some kind of transporting back to more Mars. but we haven't done calculation before and but yes, that is the actual goal. We actually have
Missions right now. So what we've gone up to is that the same of the field that is going to be traveling from us. Like we know there's a lot of complications before and after the asteroid part, but we just right now our mission was just to prove that we can actually stable the Delta V famous one.
Curiosity to stable Earth around Mars.
Yeah, it was done on exactly.
The payloads around 8,000 kilograms. Payload yeah, I think this can be budget. It's not huge.
So you're what to build it, so input and to new problems get from the with the asteroid was 4.7,000.
4.87. Whereas current technology is around 0.3.
No. Okay. I just don't think we're going to improve for 2 days. So, really amazing. Short and fine. So,
But I think figure wrong that the piece of big amount of payload cost the capacity 4 times of fuel. And then that's sort of like the 10 half now. It's not exactly a half, it's more, it depends on the function. Yeah. We have that knowledge right now.
So, for me, you've got to miss fuel critical decision is whether your half-room tethering system weighs more than fuel savings. And that's a correction or the other thing I had was probably cracking up less. So this what is spinning in some way. Half moon and asteroid, or spinning in some point and coil itself up. I think those kind of very complicated. And you probably are better off just getting a slingshot and cutting a rope rather than trying to say that's the asteroid. Is that your what would be calculation? Yeah. You don't have but it's
yeah, there was for one thing, there was actually no data on speed rate. That's right. Okay. Yeah. Second of all, like without grabbing the half-moon system is actually only one idea to brainstorm. One other idea is to use a net, perhaps. So it's getting like 2 months old. 4 months away. Maybe time not a lot of information. Unless the asteroid is the base you've got a spacecraft about 8 tons. You're not did you consider the possibility, again this is beyond my specific expertise as far as what's the possibility of using the gravitational slingshot thing rather than grab on
cut it and get a things moved like that.
Yes.
Seems a mistake.
As we said, our assumption is that the asteroid gravitational field is zero because it's just too light to have any gravitational field.
What is your that was the detail. And basically Kennedy said it was very unique solution we can keep it up like most and our Jupiter's mass system so you can't really do a slingshot at massive numbers.
Well, yeah, but we did actually consider more of it is a lunar slingshot. It's about that we decided it was a little bit beyond the scope of our project.
Do you have any feel for the number of astronauts that could potentially use this?
Well, we didn't spend a huge amount of time looking at potential asteroids. We used the asteroid, something like the asteroid database, and it added this search criteria for closest. When that pass close by the that only was on the list of about 2,000, 3,000, 4,000, and that's what certainly very poor.
Yeah, because obviously, being a three-body system, you've got to have all three to make some criteria.
And that's why we made the assumption that they would be, but in reality,
This main asteroid that we have not found yet in the facility, so we have so maybe some asteroids.
and then we do subjects of percent, something like this, saying we have to do that 90% of the outputs of the sites. So we did something for an asteroid that we you're obviously close to the displacement between the two, the asteroid and Mars isn't going to be, the minimum isn't necessarily the most important part. The minimum may require more delta D to either slow down or speed up your spacecraft to get to Mars. Maybe somewhat important and what good force here.
As well as this asteroid and Mars got an inclination difference of 0.4 degree. Yeah, 0.4 degree. So it's still a little bit low, but it's something else to work with.
So if we could extrapolate from this, the work you've done in 2 days, where do you see this heading? So this is too big for a mobile phone. This would be a set of mission design software.
Yes, so we actually have begun work on using the GMAX.
What's the GMAX?
It has tools to simulate asteroid, spacewalk missions, stuff like that. Yeah, so I guess if we are to keep on working on this project, we'll be keep on using the GMAX software to simulate our mission and so on. But that's the immediate future. Further on, we'll probably somewhat have to develop a viable capital system. And yeah, that will probably be further.
This is really the most novel aspect of what you're trying to do, the asteroid capture system.
Yeah, but that is an important part of it.
Key number 2. Oh, wait.
And you guys can always on the videos. Yeah, no, yeah, I need I need someone.
It's Michael Duncan and somewhere. Stratosphere.
Yeah, view full screen. You may want to use the mic. Thanks.
Sure. We need
Yeah.
Every time I'm insane, usually it's indigenous. I don't think I have time.
Well, you have a lot of experience. You tell me. That way.
Oh, my heart's beating. Maybe because I'm.
Okay, you ready?
Good afternoon, judges, Michael Duncan, Simone, and Stratus, and fellow participants. This is Kevin, and my name's Alexandra. We developed a proposal introducing Space Opticat. Asteroid Prospector is an educational and entertaining game. Animated characters inform and instruct players. The educational content is delivered in a clear and concise manner. The audience is introduced to asteroids and the potential threat they pose to planet Earth and humankind. The synopsis highlights a monumental historical event. 65 million years ago, a 10-kilometer wide asteroid collided with Earth. The day was devastating for the dinosaurs. Here we provide a perspective of the size of the killer asteroid by comparing it to Mount Everest. This is the interface in which the game is displayed. So, a killer asteroid is set to hit Earth, hypothetically. Space Octocat says today, NASA has assigned you, the player, on a mission to protect planet Earth. Kevin will now introduce the design aspects of the project.
My name is Kevin, and I have design and research about the UI and gamification with the other team member. So the game is going to have different levels and different complexity of each missions. So the first mission is going to be like really easy to understand, and they can understand it without manual. Even children can understand it, and they'll be like up to 1 to 10 levels. But we kind of expecting that we're going to have more levels and different versions as well. And this is a sample user interface that we're proposing now. Say the mission 1, they have to deflect the asteroids coming to the Earth and protect the Earth. And as soon as they successfully deflect the asteroid, they get rewarded. So on the top right side, there's a coin that you can see it. So they're getting the coins. And if also there's another asteroid has a collars and has a pickaxe on it. Yeah, that asteroid has there's special resources in it. So if you say you deflected the asteroid has a resource in it, then you get a resources as well. And in the later stage of the mission and the stage, we also going to provide that with the get the resources, they can upgrade the technology, and they can see the orbits or the what resources, like what's the information of this asteroid, and and maybe we could also provide like sending missiles or setting up the space center in the middle of the space, and also moving to the other planet to do another mission. Okay, so there are two major characters. One is a wise guy delivers educational contents in a fun and engaging manner. So this character is going to provide all the information how to play the game and giving like useful information. And the other character on the right side is a physical explains the future obstacles set up Octocameras concours. So this character is going to give you like missions and giving the extra information of the asteroids. So the Alex is going to continue the presentation.
Okay. And in subsequent levels, we're going to increase the complexity of the game. So introducing spaceships, weapons, awards and prizes, new environments. We're going to have the characters go into the asteroid belt and potentially mine the minerals from the asteroids. There are different kinds of asteroids, and depending on their type, whether E, M, C, or S, they can mine different minerals and get different prizes. So the Space Octocat game was brought to you by our development team, as well as the sponsors. Thank you.
We'll go over there and we'll answer questions a bit easier.
Is that your last name?
Yeah.
How do you pronounce it?
We'll take any questions.
Can you explain this slide? Just say
equipment.
And is it simply just touching and looking at it? Does it go? There's no sort of thing to touching it a certain way or?
That's the machine we want.
Yeah.
So in subsequent mission, introduce new
and that would be quite, that would be quite.
Yes, yeah. I think look, that's why we have with the as I mentioned, they learn it's like we kind of consider the space science. So we like the first thing is what is and what we can use like the asteroid. So we may have like sort of vision one. Yes. Yeah.
These,
oh, they are the minerals could be extracted from the asteroids.
uranium and
Yeah.
And asteroids have different mineral Should be really good. And hopefully we'll be able to pull it through this year.
In the event of your mission failing, you can put some assumptions of is it some sort of version if you don't successfully, then that's where what's going to happen. What's going to do? Is it just losing points or?
Yes, we do lose points, but for example, if the asteroid hits the Earth, it would degrade a little bit, and the Earth would degrade a little bit more. Instead of
I guess I'm coming from the point of view of someone who doesn't really just salty that's it. So I'm not familiar necessarily with the sense of reward and defeat. And I was rubbish at the points. So I'm just wondering if there's some that out of the process that you want to just go through.
let's do get rewarded. Let's use that money that has actually so upgrade. But hopefully we'll give fractional and utilize 3 different games. You
take weapons.
Yes.
Finally, this context weapons.
Weapons to mine the asteroid.
Okay, so tools that weapons sounds like you're saying it's about you too. Yeah.
Yes, it's true. But in the future, we may and who compete for the resource. Yes.
Well, it's full educational, but we also consider the like gamification, so you can do it, also learning. Yeah, yeah. Yeah, definitely. Yeah.
How do you see the overall message about education?
Oh, Jamaica. Go Jamaica. Okay.
Great. How do you see the overall? I guess I'm thinking that beyond the game itself, there are social just spreading the message or just Is there what's the speed? I appreciate that. I guess what I'm wondering is there, do you have the child flavor game, adult flavor, so the characters are.
Yeah, but if you think about the acrobat, it's actually like that whole adult thing. Well,
I know.
Yeah. So like, but the these asteroid things and complexity of the asteroid and how what we doing like it's like asteroid that it's probably very complicated. So like, when it's like finish the mission, essentially it's gonna get like more complicated. I think we'll have it's like a like, yeah, I mean like not only like but also the
Alright, so we don't have any other things. So I think we're going to together and we'll just have a quick chat about what I think guys over a couple of times. Do you guys have a thinking your own right? Two projects to choose from, so you have to nominate if you think you want. Maybe someone will not from their active. What makes you guys upset?
No, okay, fine. I would pick one, and he would vote. Every one of you would vote once. I'm with it. Good. I'm saying that, you guys know what to do. Yeah. I'll beat you up. I'll pick you up. Okay, yeah. You can beat me. Honestly, that's conclusion is. Yeah, dude. Let's save it.
Also, after this, do. I think there's still good. We've actually giving voting. Yeah, but right. I did like that video.
Right, everything. Space, well, evolution, radical thinking, and similar. So it's really.
Yeah. For you to be here.
Alright, okay, I think you'll be fully there.
People like our idea
no, it's I will. No, I'm on whip.
Yeah, this is like.
And what we presented made is something that seems actually people in the public or like
well, the thing is, people choices, I think, is down.
Basically, what we the bottom of the majority of us. Well, I'll say to be fair, I'm be
all these other asks.
there's nothing that's
yeah. Wait, so it's 6 No,
We can't watch. No, but we use it's only one.
It's two at the top.
No, it's one. It's only one. We only get one of them. And then so one of you get two, so one of you get one. I think so. Oh,
They're both GitHubs.
Yeah.
It's a silver one, and then there's a bronze GitHub. It's a bronze level.
Unless you call it.
GitHub is coding.
Yeah.
I don't really care about
Yeah,
the price.
I don't really care about this.
GitHub, yeah, membership. GitHub.
I do coding, but I don't use GitHub for much.
I never heard of that.
I actually haven't. I don't know. I think I have. I actually use them. It's a repository, so we can upload the code and like other users will work on it.
Maybe we should give this to the end. It's actually the end of the end.
I think put that for it. I still say. Give them. Yeah, I think it's the same.
If they win that.
Yeah, they didn't get them, so we all we get.
We already got the GitHub. Where already got the GitHub.
I suppose they're not talking about it.
No, for sure.
Alright.
So, yeah, but I think their idea is probably more idealistic.
Yeah. Oh, no.
No, we're realistic. Realistic. The awards go to that goes to
Yeah, the video goes on that.
Which that was expand upon.
Alright. Then we have a few more factors.
I need to create this. Yeah, after that.
I have to edit the video.
You know, well, you decide, you say you move it.
It's 30 seconds, right? And you know, the editing
Okay, fine.
That's like 30 minutes. 30 minutes.
30 minutes.
No,
That's fine.
5 minutes.
Yeah, these just, if you think of the job of the box, would you be more interested in a game or would you be more interested in a theory of versus Mars? Probably a game.
Yeah.
Alright,
Alright, so let's do that first.
because these people survive.
Okay, so alright. Okay, alright, so you say they let's give it to them. Say yes.
That's what I said. Like 5.
Okay, yes, that's yes. Yes. Yeah. That's right.
No, but like, I mean, like, people, it's not an international panel.
Yeah, no.
It's international hours. It is international. Well, it goes through Australian panel, and then if we go, if we went out of that, then it goes.
Well, we already have one category.
If you get supposed to fire.
No.
Yeah, best side. Can't we get 2 tries?
No, we can't. It's just one. Okay, really. Yes.
What do they most side.
Yeah.
It's your choice. It's right next to me. Cats is still in his ball. Oh, no. What? Yeah, we want to have that. I still don't get it. I still don't get it. Oh, I get it.
No, it doesn't actually go, we don't actually do this up. Not how what you do.
It's really good, but I don't know.
Well, did you want to actually do that?
I'm just saying, like, you have it on the register.
Just do this next year again and decide. And then you can continue on with this topic.
We actually talk with it, like, hey guys.
I didn't hear it.
Yeah.
Yeah.
So I'm coming back. But
Very curious.
Yeah. Okay, so the question would be, do you want to choice? Okay, yes or no? The question is put to you, yes or no?
Let's say,
That's it. We're not going to be surprised.
we are going to develop this game. Hopefully,
In the account, you already got on GitHub.
Yeah, you already get your sister.
Yeah,
so this year, we're actually going to develop interactive design by
Okay, well, what?
but yeah, that's what it is. So basically, to have it public, with public interact, whether it be useful. Yeah. Specializes in interact. So what it wants to do is engage the public and get them to interact. That's why they use it their personal license to control action. So imagine if you're able to use your personal device to control the lives of a client.
All right, okay.
Actually, Austria in September. So that's by the 4th of July, when voice is threat for each other.
Sorry. So who's okay? What are you? Who? Okay. You show of hand or Sorry. How do you want to do it?
Actually, this one you want it. Okay, well, we already told it. Our resolution, like 5 resolution, like our team resolution, we already told it.
Yes.
It means that, yeah.
They've actually got used to prize.
Unless you want to.
Okay. So you got the degree. Okay, so you guys, the judges are nominating your concept. You go through that one. And the AMP and most inspiring. We're all winners here. But
You're gonna get them.
Except for you, mate.
So what I'll get you guys to do is so make sure before Thursday they haven't completed upload content to your presentation. So you've got I'll send presentation ready, you've already got content. You don't know anything. But they need the video there for the global judges. So if they do select your project, go to global judges. We're not going to need you to go to global judges, but they'll also focus. Okay. Not just on the video. So the video, the content, all the links that you include for resources. So I mean, yeah, for 36 is hard to yeah. So after, so if you win, so all these categories, they'll select one in each category, right? That is and they'll invite those team members to come to the
Too late. How many scenes? Too late.
That's the international prize category. Yeah, you guys, I'll give you guys access to the GitHub account. So you have that your thing. If you don't want to set the thing, access. So if you have to, you can do that. Otherwise, only a couple of support. So if you have the client master, what they're offering is $300 for 1 plan. It's normally only all the data systems that are there, getting it covered, and you can pay it for weakness in benchmark reporting. And only you can test it. So, and that's for the thing. Create your own name and then you create your own personal account. And your team has 10 parts. So it's up to you guys. Let me know. They quick cover and done the actual that. Email? My email is yeah, it's So you guys want it?
Yeah. So here's one things. Okay. Well, yeah. I guess.
We can still create. Okay, yeah, like you pull things, right? And yeah, so you pull back to the file. Oh, yeah. Could you create your own individual account? And then you become part of the organization, like a team.
Oh, yeah.
And that team has private, and you guys can have a.
So there's like 10 spots there, you guys got one each. Or 2 each.
Yeah. Oh, okay.
Yeah, no, there's like 10, yeah, there's 10, yeah.
You guys got 2 spots. Just one each. Yeah.
Alright, so just. So I'll have to create that file. I'll send it to you. I'll get your emails and then I'll send you the details. Log in, create your own name, password. Rest of the day, that's it. Yeah, you can have it on my version and then
Oh, I can always, like, get something. Oh, yeah, so it's not paid.
It is, yeah, it's just a social. Yeah, it's a social, yeah. This
Yeah, you can be doing
that. Probably. Oh,
still illegal.
Let's go to.
I'm your my last stream or if you want. Yeah.
I'm 22 today. Let's have a
Are you good? Oh yeah. Alright, so
happy all.
You got any other photos to take? I'll take a photo.
All the pictures up on Dropbox. Linked it out.
You can like stand there and I'll take a picture. Hey, where's my camera, by the way?
Yeah.
Wait.
We still need to use a camera for
Yeah,
we can use a camera afterwards.
Okay, sure. You guys just want to go around there?
It's boxing sound.
No, that's too tight. I'm scared here, guys. Short people sit in front, tall people sit in the back. I'm going to do a shot. Is this like a
Yeah, it's different you board.
Is this like a official photo? Should I like write a name on the wall?
It's official.
I'll join
The judge is coming too.
Alright, let's do
It's Judge Dread of Asteroid.
we're getting with the logos.
Except the law, you are not the law.
You're like, yeah.
Physics.
That's what it is about. Into the code from.
Alright, come on, go this side.
Look over the side with the logo.
Yeah.
Alright, you want to spin the picture? Yeah.
I'm a dilettante.
Go.
I never did that. It's got a few rows.
Oh, we're doing 2 rows?
I did all 3 rows.
3 rows. Okay.
Okay, over 6 foot, you're in the back.
Nah, it's the shorter people in the back. You're gonna get marked.
Do you need to hold on, is it autofocus or try
That box.
yeah.
Let's give it
Alright, get your smile. 3, 2, 1. Let's check.
You find if you name the first asteroid discovered series. Notice one.
Okay, cool. I'll do one for you.
Let's go another one. 3, 2, 1. And let's get a silly one. Silly one.
I'm out of ideas. I've done it twice already.
Sleeping you like that.
Oi.
Sorry.
There we go, I like that. Alright. Ready, set, go. Oh, there we go.
That's just that means.
Guess what? The best, what was it? Best mission?
Mission concept, yep.
What was that project? We get like this. We get to look good in the same house. You get like
Guys, team spirit.
Yeah.
1, 2, 3. Oh, whoa. Okay.
Yeah, we'll see that.
Yeah, like, where is it?
No.
Which one is all come? Yeah.
Alright, well, like, I mean, how do people say?
Oh, so you gotta get on there. Come on, come on.
Let's go.
Go. 1, 2, 3. Yeah.
So you want your team to get a photo?
Yeah, one missing.
Yeah, we have one missing. We have one missing as well. So.
Yeah, look up.
We only four.
I don't think so.
They steal you, so you.
It's very blurry.
That's all. They steal it.
And they never get it back. 3, 2, 1.
Very blurry.
Yeah, because I think, yeah, just bring it.
Can you make it?
Yes.
That's good. Okay. I have to modify this time. And, well, I never.
Oh, so you want the actual?
Yeah. Raise the set.
Maybe? Maybe.
That's good. One of them.
Does it make you feel special? Okay, where's it?
Yeah.
Like, okay. Yeah, what else do you need? That can be done in the next 30 minutes because I'm going.
We done that. I need it. I need a.
What do you need from us?
You take it to the restaurant.
Like they actually work out.
Yeah, you have to video recording something. Video recording something.
Oh, but it's funny, when I do the schools are
That one and this 7 on the
most of the we shot any school.
Yeah, but I don't have this. I tried. We always no, not time. I think I have. Because I don't have a Gmail. So,
But some say,
so we can pay you.
well, I'm doing it for
Unless you got Gmail. If you no, I need to files. Actually, yeah, I don't know how to run that. You can press that. Yeah, but you gotta take 4 weeks. Otherwise, you can play it while you animate. So you gotta press 4. Yeah, 4. That's just the type of yeah.
what we got good luck catching that answer.
Other question?
Yeah. To take a picture, do you mean from the thing we project inside, or do you mean Brisbane's not a great place? Brisbane's not a great place to come outside. Any city, any urban environment. Yeah, it's just you've got to get to a week, so the other place, no, even just go to it's really. Oh, you can do, but when it's between March and November, because it's like you'll do when we've got 2 to 1 with our duty, one can do that, one business. Then we do probably do manage more less and sort of things you look at with radios. Where to start. So galaxies. Where would you put it to say? There. We do Facebook. There is a try it. You put something with
No, I'll hang out with you guys, but I'm not gonna find it. Yeah.
That's great.
And I'm just like, eat that, like, what the fuck?
Guys, it's been nice meeting you guys. I'm coming towards about 5 minutes. Yeah, people are like coming to conference. I'll leave at 5. And we should like touch it. Like, I'm more.
Yeah, do you know what, where they're like now, on the,
yeah, I'll give you a No idea what they are now. Wait, oh, this is for the actual. This is someone's pet.
So you've taken whiteboards out of the other room. I don't know which one.
What would you wish? I suggest.
That's all, folks.
Wait, it's a live stream for going?
So we got some more whiteboards. I'll put them on there. Upstairs.
Those ones are okay, it's the other rooms.
Yeah. That goes with that. I'll take that.
So the brown one's going in 502.
Yeah.
Yeah.
Is this stream still going?
Stream's still going. I'll turn it off now.